Let us start. Today we want to discuss solid state, right? We have already discussed about gaseous states and liquid state. Today we are going to see solid state. As usual, I am selecting the simple questions first, then harder units. Okay, let us start now. Okay. What about the first one? Which of the following is true about the value of refractive index of quartz glass? The term is derived directly from NCERT textbook. You know, quartz is crystalline, but quartz glass means amorphous. What about the property of amorphous here? You know, amorphous are isotropic or anisotropic. Crystalline solids are anisotropic. It possesses different properties in different directions. Different properties like electrical conductivity, refractive indices, etc. are different in different directions for crystalline solids. But for amorphous solids, you know, these properties are same in all directions. So what will be your answer? We want to consider amorphous solids. For amorphous solids, it is same in all directions. First answer put by Anu. Okay, let me go to the next question. What about this one? Not correct about molecular crystal. They are generally soft and compressible is correct. They are good conductors, electricity is wrong. You know, molecular solids like pure water, carbon dioxide, they cannot conduct electricity either in solid state or in molten state. So this statement is wrong. So you selected as option B. Now let me go to the next question. What about this one? Which of the following forms molecular solid when solidified? Molecular solid. What about the first one? Ionic. Silicon dioxide is silica. Silica is network, covalent network solid. Whereas carbon dioxide is molecular. You know, in carbon dioxide, simple molecules exist in the lattice site. What about silica? Silica is network solid, isn't it? Covalent network solid. So you want to select the molecular solid, that is carbon dioxide. You know, sodium chloride or rock salt is ionic. Go to this one. Come on. Very first that you know, malleability, ductility, etc. illustrate what? These are all for the properties of metallic solids. Now further explanation needed. What about the next one? Crystal X is very hard. Very hard. Harder solids are generally what? Either ionic or it may be covalent network solid. But very hard generally stands for what? Covalent network solid. And again that point is illustrated here. They are insulator in solid state and in molten state. Suppose the question is like this. It is hard but can conduct electricity in molten state, you will say it is ionic. But here they cannot conduct electricity either in solid state or in molten state, suggest they are covalent network solid. But you know, there is one covalent network solid they can conduct electricity, that is graphite. Clear? Now let me go to the next one. What about this? Not correct regarding diamond and graphite. You know, in diamond, each carbon is sp3 hybridized and it possesses covalent network geometry. But graphite possesses hexagonal layer-like structure. Between the layer, there is a very weak van der Waals forces. So, diamond, they say the last statement is apparently wrong. Diamond is not layered, but graphite is layered, and in between the layer, there is a very weak van der Waals forces. So, one layer can easily slide over the other. Hence, it can act as a solid lubricant. Clear? Now, let me go to this one. What about this one? Question number 7. Examples of few solids are given below. Find out the example which is not correctly matched. You know, sodium chloride, zinc blend, they are ionic. Hydrogen and iodide are molecular solid. They are not covalent solid. They are covalent molecules. But covalent molecules will not form covalent solid, but they form molecular solid. What is the difference between covalent solid and molecular solid? In covalent solid, atoms are directly held by covalent bond and it will give rise to very giant units. But in molecular solids, the simple molecule exists in the lattice site. Okay, so this is not covalent, but it is molecular. Ice, you know, is molecular. Now what about the next one? You know this parameter, no sides are equal, but all angles are equal to 90 degree. Just like, you know, your notebook, instrument box, What about it? It is orthorhombic. All sides are not equal. No sides are equal, but all angles are 90 degree. Just like this length differ from breadth, it is different from height, but all angles are 90 degree. Our notebook, instrument box, etc., or matchbox, etc., are orthorhombic. What about this one? More than one Bravais lattice. Hexagonal, it possesses only simple primitive unit cell only. For hexagonal, primitive unit cell present. Triclinic also there is primitive unit cell. But for rhombohedral also primitive. Monoclinic possesses two. What are they? Primitive and end-centered. What are the Bravais points occupying? Where, in the case of cubic, there may be primitive cubic or body-centered cubic, and it can be what? Face-centered cubic. There is no end-centered cubic. Please don't forget. But tetragonal system, that can have two. What are they? One is primitive and other one is body-centered. There is no face-centered or end-centered. What about orthorhombic? It is the only one system having all the four. There is primitive unit cell, body-centered unit cell, face-centered unit cell, and also end-centered. That is the speciality of orthorhombic. Rhombohedral, there is only one, primitive. Hexagonal, there is only one. But monoclinic, primitive and end-centered. But for triclinic, there is only one, that is primitive. Clear? So here the answer is monoclinic. What about this one? Monoclinic. What is the speciality? Monoclinic, maybe this year they may focus based on monoclinic crystallography. Okay, no sides are equal, but alpha and gamma are equal, but beta should not be equal. Alpha and gamma is equal, and alpha and gamma equal to 90 degree. So that conveys the option D. What about the same question? Here also you can see A not equal to B not equal to C, but alpha equal to gamma. So that should be what? Monoclinic. Please don't forget, beta should not be equal to 90 degree. What about this one? Question number 12. What about here? No sides are equal, no angles are equal to 90 degree. That is the most unsymmetric system. What will be that? That should be triclinic. Here, what about question number 13? Contribution of particle. Corner will contribute how many portion? 1 by 8. Particle from the corner will contribute 1 by 8. All of you know, I think. What about the edge center? Edge center will give contribution to 1 by 4. How do you got corner contribution 1 by 8? You know that one corner is actually surrounded by 8 unit cell, isn't it? If you consider cubic unit cell, one corner, suppose you are considering a particle or sphere over the corner, and this corner shared actually by 4 unit cell. 4 unit cell is shown here, and exactly 4 units is behind to it. So a sphere in the corner give contribution 1 by 8 to the unit cell. One sphere shared by 8 unit cell. And phase center, suppose a particle is present in the phase center, half part goes to one unit cell, the other half goes to the next unit cell. So the contribution from the phase center is half. Body center belong to that unit cell. So corner from corner, 1 by 8, A goes to 2. And what about B? Edge goes to 1 by 4. A 2, B 3. So the correct answer is option B. All of you got it. What about question number 14? What about question number 14? This is an FCC arrangement. They want to find out this location. For an FCC arrangement, the edge center and this body center corresponds to what? Edge center and body center corresponds to octahedral void. Please don't forget to locate octahedral voids. For an octahedral voids, for an FCC arrangement, where is this octahedral sites located? Octahedral sites are edge centers and also in the body center. For an FCC arrangement, octahedral voids are in the edge center and in the body center. You know how to locate tetrahedral voids? To locate tetrahedral voids, what will you do? You exactly divide this unit cell into 8 simple cubes. Okay, suppose you are considering a FCC unit cell, and this FCC unit cell are exactly divided into 8 simple small cubes. You just divide the FCC unit cell exactly into 8 very small cubes. One FCC unit cell divided into 8 very small cubes. And if you consider center of each cube, that will be the site of tetrahedral void. If you consider the center of each small cube, that means here you can see 8 tetrahedral sites. Am I right? What about octahedral sites? I told you edge center and body center. Please don't forget it. So here it is what? It is an octahedral site. It is edge center. Edge center and body center in FCC system is octahedral voids. Clear now? Now let me go to the next one. What about here? The relation between radius of the void and radius of the sphere. For an octahedral void, we have already derived this result. Radius of the void divided by the radius of the sphere should be equal to, for an octahedral void, 0.414. What about for a tetrahedral void? For a tetrahedral void, don't forget, R void by R sphere should be equal to 0.225. For a tetrahedral void, R radius of the void divided by radius of the sphere you placed should be 0.225. For an octahedral void, radius of the void divided by radius of the sphere is derived as 0.414. Okay, so what will be the correct answer here? So the radius of the void should be 0.414 times radius of the sphere. For a tetrahedral void, don't forget, radius of the void equal to 0.225 into radius of the sphere. What about here? They say copper, where is this copper situated? It forms CCP. CCP means FCC. That means copper present in corner and also in face centers. CCP is other word for face centered cubic. Face centered cubic means they present in the corners and also in the center of each faces. There are 8 corners, each corner will contribute to 1 by 8. So 1 by 8 into 8 plus half of the 6. That will be equal to 4. There are 4 copper units. What about silver? They say silver present in edge centers. Edge center means what? Contribution is 1 by 4. 1 edge center shared by 4 unit cell, So contribution from the edge center is 1 by 4. How many edges are there? 12 edges. So silver is 3. What about gold? There is only one gold. How do you know that? They present in the body center that cannot be shared. So that copper 4, silver 3, gold 1. Answer you got as C. Okay. What about this one? Which of the following is not correct about hexagonal close packing? You know that all these are introductory question. Harder question we want to consider. Before that you should get a thorough basis about it. Okay. In HCP atoms occupy 74. Do you agree with this statement? Yes. Whether it is CCP or HCP, 74% is utilized and the 26% appears as void. What about the B option? AB packing in which third layer aligned with the same first layer, right? A, B, then comes what? A. That means the first layer and third layer looks the same way. So then A, B, then comes A. And what about ABC? First layer, second layer, third layer and the fourth layer is similar to what? Similar to the first layer. That is ABC. Now, molybdenum, magnesium, beryllium, zinc. All of you know the term mom, G, bezel. We used to say they are all HCP pattern, Coordination number, is it coordination number 6? No. Overall coordination in 3-dimensional packing of HCP and CCP will be 12. So this is the wrong statement. But please don't forget a tricky question. If it is HCP in 2D, what is the coordination number? No doubt it is 6. If they say coordination number, if they ask to find out the coordination number in HCP in 2 dimension, if HCP in 2 dimension is considered, one sphere is in contact with the 6 sphere. So the coordination number is 6. Clear? But simply they say HCP, that stands for 3-dimensional packing. For 3-dimensional packing, whether it is HCP or CCP, overall coordination number is 12. Now coming to question number 18. Coordination number of metal crystallizes in HCP. That's same repeating question, It is coordination number 12. What about question number 19? Total number of tetrahedral void in face-centered unit cell. I told you, if you consider a face-centered cubic unit cell and if you divide this unit cell into 8 equal parts, that means if you take a very small cube, there are 8 small cubes and center of each cube if you analyze, that is the site for tetrahedral voids. So there are 8 tetrahedral voids within the face-centered cubic unit cell. Clear? There are 8 tetrahedral voids. Now coming to how many of you? Don't write. Anupama got option A, but correct answer is option B. Okay. How do you got option A, Tanzir? Do you got it? Actually, tetrahedral site means what? Tetrahedral site means the center of small cubes. You just take a FCC unit cell as a big cube and divide that cube into 8 equal parts. Okay. Clear now? Let me go to the next one. Question number 20. Square close packing in 2D. Square close packing in 2D. What do you mean by square close packing? Vertical and horizontal alignment. Vertical and horizontal alignment is called square close packing in 2D. If you place the second row in the depression of the first row, we call it as HCP in 2D. This is called HCP in 2D. You know why they are called HCP in 2D? One sphere is in contact with the 6 spheres, and if the centers of these 6 spheres are joined, you will get a regular hexagon. That is why you call it as hexagonal close packing in 2D. But vertical and horizontal alignment, if you consider, one sphere is in contact with 4 other spheres. You can see 4 spheres in contact with it, and the center of each spheres are joined. If you join the center of each sphere, you will get a square. So it is called square close packing in 2D. So what about the coordination number 4? One sphere is in contact with the 4 sphere. In HCP, what is the coordination number? HCP in 2D, the coordination number is 6. Clear now? Let me explain octahedral void, please. Eyes, what is the doubt with octahedral void? That question we are actually going to do. If you consider FCC unit cell, the location of octahedral voids I already explained. That is in the edge center and in the body center. Clear? Octahedral void means what? Suppose you are placing the sphere like this. You are placing the sphere in this way. That is in HCP in 2D. Okay. If you are placing the spheres in HCP in 2D. And the second layer is placed. How is second layer placed? In the depression of the first layer. Suppose you place the second layer in this way. You are placing the second layer in the depression of the first layer. I hope you can see. Now, above this second layer, you can see 2 types of voids. As you are following, I will explain that again. That is, she need an explanation about octahedral void. It is so simple. Anyway, you just think in this way. You are arranging the spheres in 2D. Okay, you are arranging the spheres in 2D of hexagonal close packing. Like this. Now you are arranging the sphere. You are placing the second layer above this in such a way that the depression of the first layer is covered by the second layer. Please draw it. That is, you can draw over here, you can draw over here, you can draw over here. Here also you can, like this. Clear? Now, if you analyze the second layer, the depression in the second layer, you can see there are 2 types of void. What are they? Suppose you are considering this void. If you look through that void, you can see the first layer there. Am I right? Then the void is called a tetrahedral void. I hope it is clear. As you are following, this is the first layer and you are placing the second layer like this. And if you look through this void of the second layer, you can see the first layer. Then this void is called a tetrahedral void. Okay. Now, you just see this void. This void where you can see a first layer like this and you can see a second layer over like this. These 2 voids are combined. Do you got it? I will draw it again. This is the first layer. Suppose this is the first layer and this is the second layer. And you can see that these 2 layers, the voids of each layer is combined and you are now getting an octahedral void. I hope you got it. I suppose you are placing the third layer in such a way that covering the tetrahedral void of the second layer. That means if you cover this void by using the third layer, you are placing the third layer in such a way that to cover this void. What will happen? You are placing a sphere over this. Automatically that layer will imitate the first layer. This layer you place in such a way that in order to hide the tetrahedral void of the second layer, that will automatically imitate the first layer. Then that layer is called again A. So A, B, A, because it repeats the A. Clear? Suppose you are covering the octahedral void of the second layer. Suppose you are covering the third layer by placing the octahedral void. It is a new layer formation. Then you call it as ABC, ABC like that. Okay. So this will be the correct option C. Clear now? I hope you got it. And now coming to question number 21. What about question number 21? See, 0.155 to 0.225. But suppose the radius ratio is 0.155 to 0.225. You are all familiar with the radius ratio, right? Suppose radius of the void by radius of the sphere is 0.22155 to 0.225. Call it as what? It is planar triangular arrangement with coordination number 3. What about this? Coordination number 4. This rule is called what? Radius ratio rule. If the radius of the void divided by radius of the sphere, radius of the cation by radius of the anion is 0.414 to 0.732. We call it as octahedral arrangement with the coordination number 6. So what will be the correct answer? A goes to 3. A goes to 3. The correct answer is option D. Okay. Clear now? I hope all of you following. Okay. Let me go to question number 22. What about this? Repeating. R plus by R minus. R plus by R minus. What about it? Radius of the cation by radius of the anion. 0.225 to 0.414. Please don't forget. This is octahedral arrangement. Isn't it? It's an octahedral or tetrahedral. It's a tetrahedral arrangement. It's a tetrahedral arrangement. What about the coordination number? 4. For an octahedral arrangement, the radius ratio should be 0.414 to 0.732, right? And the coordination number becomes 6. Clear now? Let me go to question number 23. Radius of the cation and radius of the anion. Radius ratio is 0.524. Come on. If R plus by R minus is ranging between 0.414 to 0.732. If R plus by R minus is in this range, we will say this is octahedral arrangement with the coordination number 6. Don't forget. What about coordination number 4? I told you 0.225 to 0.414. Okay. Let me go to question number 24. AB is a rock salt type. What about the cation radius? 120. What about rock salt type? Rock salt type. AB crystal rock salt type means is an octahedral arrangement. Please don't forget. Zinc blend type means what? Tetrahedral arrangement. That means R plus by R minus should be ranging between 0.225 to 0.414. If it is rock salt type, if it is of rock salt type, you can say what? R plus by R minus should range between 0.414 to 0.732. If cesium chloride type, you should say what? R plus by R minus is ranging between 0.732 to 1. Clear now? So here the radius ratio should be ranging between what? 0.414 to 0.732. Why? This is of rock salt type. Rock salt type means, don't forget, radius ratio should range between 0.414 to 0.732. If it is of zinc blend type, don't forget, the ratio should be 0.225 to 0.414. For a body-centered cubic arrangement, cesium chloride arrangement, the radius ratio range between 0.732 to 1. Clear now? So here the arrangement is rock salt. So we can say what? R plus by R minus should range between what? R plus by R minus should range between 0.414 to 0.732. But what is asked here is minimum value of B minus. So minimum value of B minus. Isn't it? So we want to equate it to what? 0.414 or 0.732. Suppose you are equating to 0.414. What will you get? R minus is equal to R plus by 0.414. Clear now? So what will you get? What is R plus? 120 divided by 0.414. We are equating to a limiting value. Clear now? So it should be 0.414. Suppose if you solve it, to how much you got? What is your expectation? 1200 by 4, nearly 300. So I hope you got the answer as C. Am I right? Naja, you got it? Okay. Vishnu KV, what about Vishnu? He said, suppose it is equated to 0.732, what will happen? That was his doubt. Suppose you are considering rock salt type, R plus by R minus value can be from 0.414 to 0.732. That is the maximum limit is 0.732, right? So if you take R plus by 0.732, you will get what? Radius of the anion. Isn't it? So R plus by 0.732 will be the minimum value. Based on that, what can be the answer? If you take that value, suppose you are limiting to a 0.732, you will get what? Clearly R plus by 0.73 is less than 290. What can be that value? 120 divided by, actually we are discussed here is maximum value. Am I right? So 0.73, if you divide by that, you are expecting which value here? 1200. There is no such answer, I think, here. Am I right? Okay. Coming to question number 25. What about question number 25? What about the coordination number? I hope you follow. What about question number 25? R plus by R minus, if you find out, what will you get? Cation radius is 0.98. Anion radius is 1.81. If you divide, you will get nearly 0.5. 0.5 is ranging between 0.414 to 0.732. Then what will you say? The coordination number is 6. The arrangement is called rock salt type. Suppose you are dividing R plus with R minus, and if the value is in between 0.414 to 0.732, arrangement is called rock salt type, and the coordination number is 6. Okay. Question number 26, come on. What about question number 26? Two elements X and Y. X atoms are at the corners of the cube, while Y atoms are the face centers. You know what about the contribution of corners? 1 by 8. How many corners are there for a cube? 8. So X is 1. What about Y particles? Y present where? In the face centers. What is the contribution from face center? Half. How many faces are there? 6. So how many Y particle? 3. So what will be that? XY3. I hope it is clear. Now let me go to question number 27. What about this? A compound is formed by two element Y and Z. The element Z forms CCP. Atoms of Y, 1/3 of the tetrahedral void, which is arranged CCP. Z is arranged in CCP. Immediately you should take Z as 1 mole. Please don't forget this procedure. If one thing is arranged in CCP or HCP, you should immediately take that as 1 mole. You just take it as 1 mole. You are taking 1 mole Z. So how many tetrahedral void will be there? Number of tetrahedral void will be double the number of spheres. So if you place 1 mole Z, there will be 2 mole tetrahedral void. So 2 mole tetrahedral void is there, but out of that 1/3 of the tetrahedral void is occupied by Y. So Y is 2 by 3, Z is 1. So Y2, Z3. I hope you got it. I took Z as 1 mole. So automatically tetrahedral void will be double. So 2 mole. So how many Z particles are there? They say Z particle is 1. So how many Y particles are there? 1/3 of the 2 mole. Clear? So that means 2 by 3. So Y 2 by 3, Z1. So Y2, Z3. Now coming to question number 28. What about here? They say in a cubic close packed arrangement of mixed oxide, the lattice composed of oxide ions. So immediately you take what? Oxide ion is 1 mole, isn't it? Oxide ion is 1 mole because they form lattice. So oxide ion is taken as 1 mole. Okay. Then 1/8 of the tetrahedral void. How many tetrahedral void will be there? 2 mole. Out of 4, 1 by 8 of it occupied by A. So out of 2 mole tetrahedral void, only 1 by 8 is occupied by A. Clear? Now, what about octahedral voids? There will be 1 mole octahedral void. Number of sphere and number of octahedral void will be equal. If 1 mole oxide ion is there, there will be 1 mole octahedral void. Out of this 1 mole, half of the octahedral void occupied by B. So B occupied by half of the octahedral void. So you can say A 1 by 4. What about B? 1 by 2. Oxide ion is 1. You can multiply throughout by 4. What will you get? A, B2, O4. Am I right? I got option D. I hope all of you got option D, right? Let me go to question number 29. What about question number 29? Cubic solid made up of 2 elements P and Q. Atoms of P are present at the corners of the cube and Q present at the body center. What about the contribution? And then what is the formula of P and Q? How will you write? P and Q is there. P is present where? Corners of the cube. How many corners are there? 8 corners. What is the contribution? 1 by 8. Where will be this Q? Present in the body center. That cannot be shared. So P, Q. Isn't it? What about the coordination? That means you are placing Q in the body center, P is placed in the corners. P present in the corners, Q in the body center. Come on, say one Q is surrounded by how many P particles? One body center particle is Q, and this body center particle is arranged by or covered by, you can say the Q is in contact with 8P. So the coordination number of Q is what? 8. What about the coordination number of P? That also 8. How do you got that 8? You just take another cube like this. You just extrapolate this unit cell. That means you can take unit cell like this, and you can see that there will be a Q particle, here will be Q, here will be Q, and that way you can see this P is surrounded by Q here, 4Q here, and exactly 4Q in front of it. So one P is surrounded by 8Q particle. So the coordination is 8-8 coordination. Isn't it? What do you mean by the coordination of Q is 8? That means one Q is surrounded by 8 P particle. Same way, one P particle is surrounded by 8 Q particle. So the coordination is 8-8 coordination. Body centered cubic arrangement. Okay. I hope you are all following. Any doubts in it? Clear now? Let me go to the next one. What about question number 30? How many chloride ions are surrounding sodium ion in sodium chloride crystal? Gauri, you got that? What about this one? Particles present in the corners and Q in the body center. Gauri, you got it or not? I hope you are followed. Let me go to the next question. See this question. How many chloride ions are surrounding sodium ion in sodium chloride crystal? Gauri, one vegadu parne. Sodium chloride. Anyway, you are going to read the question in English, isn't it? So that will be better. So sodium chloride crystal. What about sodium chloride crystal? You please draw the sodium chloride crystal here. In sodium chloride crystal, you don't forget chloride ions are arranged in FCC. Sodium ions are present in octahedral voids. Gauri, you please write it. Sodium ions are arranged in octahedral voids and chloride ions are in FCC. All of you please draw rock salt structure. Chloride ions are in FCC. That means chloride ions are arranged in all corners, and also these chloride ions are present in the phase centers. You can place the chloride ions in the phase centers also. Chloride ions are in FCC. That means chloride ions are in the corners and also chloride ions are in the phase centers. You draw it. Chloride ions can be placed in the phase centers and also in the corners. Clear? What about sodium ions? They are in the octahedral voids. What about octahedral voids? They are in the edge center and in the body center. So you place it. Sodium ions. Sodium ions are in the octahedral voids. That means they are placed in the edge centers and also in the body centers. They are placed in the edge centers and also in the body center. The sodium ions are present in the edge center and also in the body center. This is the rock salt arrangement. Octahedral site, don't forget, they are the location at the edge center and in the body center. So how many chloride ions are surrounding sodium ions? You can see that, suppose you are considering this sodium ion. You can locate this sodium ion here. You just extrapolate this line to the nearest unit cell, and again you can extrapolate like this. Now you can see that there is chloride ion here, there is also chloride ion here also. Now if you take this sodium ion, how many chloride ions are surrounding to it? 6. How do you got the 6? That is 4 chloride ions are in the same plane. One chloride ion exactly above to it. One chloride ion is below to it. So one sodium ion surrounded by 6 chloride ion. This arrangement is called octahedral arrangement. Or you can say the 6 chloride ion form an octahedron and the middle of it, that is the octahedral void occupied by the sodium ion. Clear? So sodium ion surrounded by how many chloride ion? 6 chloride ion. I hope you got it. Clear now? Now so don't forget, rock salt type means chloride ions are in FCC, sodium ions are in the edge centers and body center. edge centers and body centers are collectively called octahedral site. Clear now? Let me go to that. Okay. Sodium. Ashifa, how do you got 8 sodium ion? How many chloride ions surrounded by 1 sodium ion? 1 sodium ion surrounded by 6 chloride ion, and same way 1 chloride ion surrounded by 6 sodium ion also. There will be 6 sodium ion. See, if you consider this chloride, if you extrapolate over here, you can see that sodium ion here, here also sodium ion, here you can see a sodium ion, and if you combine all these things, 4 sodium ion in the plane, 1 sodium ion above to it, 1 sodium ion is below to it. So 1 chloride surrounded by 6 sodium ion, 1 sodium ion surrounded by 6 chloride ion, we will say rock salt is 6-6 coordination. Don't forget. Now coming to again in NaCl, what about NaCl? I told you all octahedral voids are occupied by sodium ion, chloride ions are in FCC. Clear now? Where is this octahedral site? Edge center and in the body center. What about question number 32? Don't forget, when sodium chloride crystal having 6-6 coordination, any crystal having 6-6 coordination is subjected to high pressure, it become 8-8 coordination. That means cesium chloride type. 8-8 coordination means cesium chloride type. You know what about cesium chloride type? That means chloride ions are in the corners and sodium ion in the body center. Then it is called cesium chloride type. That means when pressure is applied, 6-6 coordination transformed to 8-8 coordination. When 8-8 coordination system is heated, it becomes 6-6 coordination. So 6-6 converted to 8-8 by applying high pressure. Okay. Now coming to question number 33. Sodium chloride type. You know chloride ions are in CCP, sodium ion, half of the octahedral void is wrong. All octahedral voids are occupied by sodium ion. What about zinc blend? Don't forget sulfide ions are in CCP or FCC, you can say. Zn2 plus ions are in alternate tetrahedral voids, correct? In fluorite structure, these two are not now in your textbook. Fluorite, you know, calcium ion in CCP, fluoride ion present in all tetrahedral void. O2 minus ion CCP while Na plus in all tetrahedral void. So this is called fluorite type, this is called anti-fluorite type, this is called rock salt type, zinc blend type. So rock salt, zinc blend, fluorite, anti-fluorites are given. I hope you are following. Let me go to the next question. What about this one? In face-centered cubic cell, what about edge length? You know, in face-centered cubic, please don't forget, simple cubic means, you know, particles are present only at the corners. So particles in the corners are in actual contact. Simple cubic means all corner particles are in actual contact. Then you can say the edge length become equal to 2r. But in face-centered cubic means what? The particles in the corner are not in actual contact. Why? The corners particles are, if they are in actual contact, you cannot place identical sphere in the face center. Isn't it? So particles in the corners are not in actual contact in FCC. But you can say, if the edge length is A, what about this face diagonal? A root 2. In that A root 2, how many R is present? There are 4 R present. So you can say A root 2 equal to 4R. So in simple cubic, A equal to 2R. For face-centered cubic, A root 2 equal to 4R. What about body-centered cubic? Do you think in body-centered arrangement, particles in the corners are in actual contact? No, never. Because these particles are in contact with the sphere in the body center. I hope you are following. Particles in the corners are not in actual contact in the case of body-centered cubic. Instead, all the corner particles are in contact with particle in the body center. So you can say, if you take the body diagonal, what about body diagonal? A root 3. How many R are there? 1, 2, 3, 4. So you can say A root 3 equal to 4R. Please don't forget, for a simple cubic, A equal to 2R. For face-centered cubic, A root 2 equal to 4R. For a body-centered cubic, A root 3 equal to 4R. But here it is face-centered cubic. You can say a root 2 equal to 4r. So what will be a? 4r by root 3. So the correct option is option A. 4r by root 2. In the case of face-centered cubic, it is 4r by root 2. Clear now? I hope you got it. Now let me go to question number 35. What about question number 35? It is face-centered cubic. Immediately what came to your mind? Face-centered cubic, immediately you can say what? A root 2 equal to 4r. What is the shortest distance between any two nuclei of the atom? You know that shortest distance is obtained from the corner to a face-centered particle. So the corner particle is in contact with a particle in the face center. That will be the shortest distance. That is exactly half of the face center, face diagonal. Do you agree with me? If you take this as face diagonal, that is a root 2, and if you take the half of it, you will get the shortest distance. Please don't forget, the shortest distance is not edge length. Why? Particles in the corners are not in actual contact. Particles in the corner is in contact with the particle in the face center. So if you take a corner particle to the face center particle, you can see what? You can see face diagonal by 2. That is a root 2 by 2. A root 2 by 2 is what? That is what you want to find out. Isn't it? What is A given? A is given as 862. So 862 into 1.414 divided by 2. So you can take 431 into 1.41. So approximately you can say it should be nearly 600. How do you know that? You know 400 into 1.5 is 600. So clearly the answer should be option D. Do you agree with me? Okay. Afraid, you got it. Let me go to the next one. Which one is B? Nusaira got us. Okay, correct answer. Now let me go to question number 36. What about question number 36? Come on. Edge length of sodium chloride unit cell. What about sodium chloride unit cell? I told you. In sodium chloride unit cell, please don't forget, chloride ions are in FCC. Sodium ions are in the edge centers and body center. Isn't it? So chloride ions are in FCC means chloride ions are in the corner and also in the face center. So chloride ions are in FCC. Chloride ions are situated in corner and also in face center. What about sodium ion? They are in the octahedral void. Where is this octahedral void located? Edge center and in the body center. So in the edge center there is sodium ion. Clear? So don't forget, in rock salt structure, 2 anion radius plus 2 cation radius will give you edge length. This is very, very important. For a rock salt structure means anions generally present at the corners and cation is in the edge center. So if you take the edge length in rock salt type, there will be 2 anion radius and a 2 cation radius. So R plus by R minus if you take, you can see half of the edge length. What is given here? Given is chloride ion radius 181. So cation radius plus 181 should give you A by 2. A by 2 means what? 282. Am I right? 564 by 2, 282, right? So what will be cation radius? 282 minus 181. So you can say what? It should be 101 picometer. Clear now? Let me go to question number 37. What about question number 37? FCC. FCC, immediately what came to your mind? A root 2 equal to 4R. In FCC, A root 2 equal to 4R. Now, what about, what do you want to find out here? R. So what is R here? A root 2 by 4. What is A here? 361 into 1.414 by 4. You can take 4 nearly 90 times. 90 into 1.41 type. 90 into 1.4 you are doing, right? Am I right? How much you got? 1.4 into 90 approximately. 4 9s are 36. Nearly 127. Do you agree with me? Am I right? Question number 37 answer is C. Okay. Let me go to next one. Question number 38. What about question number 38? What do you want to find out? total volume of atom present in FCC unit cell. In FCC unit cell, how many particles per unit cells are there? In FCC, there are 4 spheres per unit cell. Am I right? In FCC, what is the rank of FCC? 4. How do you got that 4? There, you know, in FCC, 8 corners and half of the face centers. 6 face centers. What about the contribution from face center? Half. So, you know, the rank is 4. There are 4 spheres in that unit cell. So, that one sphere has the volume 4 by 3 pi r cube. So, there are 4 such spheres. So, what will be the correct answer? 16 by 3 pi r cube. Clear now? Okay. What about question number 39? What do you want to find out the relation here? Body centered cubic is there. You want to find out atomic radius and edge length. Immediately what came to your mind? Body centered cubic. A root 3 equal to 4r. What do you want to find out? R. R equal to A root 3 by 4. I think the correct answer is option C, right? Now let me go to question number 40. Now coming to question number 40. Edge length of unit cell of chromium metal is 287 with the BCC arrangement. BCC. What came to your mind? A root 3 equal to 4r. Isn't it? What do you want to find out here? R. So how will you find out? A root 3 by 4r. What is A here? 287 into root 3, 1.732 by 4. That's what you are doing. Can you expect the answer? So approximately you can say what? 7 4s are 28. Nearly what? Nearly 72 if you take. 72 into 1.7 that you want to find out. If you take 72 into 2, it is around 140, isn't it? 140 for something. But you can omit this option. Therefore, this 3 can be omitted. So, only possible option here is A. Do you agree with me? Now, let me go to question number 41. What about question number 41? See, fraction of total volume occupied by atom present in simple cubic. Come on. In simple cubic, you know the packing fraction is pi by 6. How do you got that pi by 6? Simple cubic means what? Particle present only at the corners. Particle present only at the corners. What about the rank of simple cubic? 1. How do you got it? Each corner will contribute 1 by 8. How many corners? 8 corners. So how many sphere? 1 sphere is occupied. So occupied volume is 1 sphere. What about the volume of the sphere? 4 by 3 pi r cube. What about the volume of the unit cell provided? A cube. For a simple cubic, what is the relation between A and R? A equal to 2R. So you can say what? 4 by 3 pi r cube divided by, what is A? 2R. So take the 2R cube. R cube get cancelled. So you can say what? 4 pi divided by 2 cube is 8. 8 3s are 24. 4 cancelled in 24, you will get pi by 6. Clear now? So for simple cubic, packing fraction is pi by 6. What about question number 42? Does not represent. Can you find out? Simple cubic, you know, A equal to 2R, R equal to A by 2. Face-centered cubic, it is wrong. You know what is the relation? 4R equal to A root 2, so R equal to, what will be that? A root 2 by 4, or you can say A by 2 root 2. So, body-centered cubic, what about that? You know, body-centered cubic, 4R equal to A root 3. So, the wrong one is C. Coming to question number 43. What about question number 43 here? Radius of the largest sphere fits properly at the center of the edge of the body-centered cubic unit cell. How will you find out? This is slightly difficult. How will you find out this question? What you find out is largest sphere that can be placed in the edge center. The arrangement is what? Body-centered cubic. In the body-centered cubic, you know, the particles in the corners are not in actual contact. Isn't it? The spheres in the corners are not in actual contact because you need to place identical sphere in the body center. So all the particles from the corners, corner particles are in actual contact with the particle in the body center. So you can say what you want to find out here is you want to find out the maximum radius or what do you want? Radius. Maximum radius of the sphere that you can place in the here in this width. Do you got that question? What the question asked? The radius of the largest sphere which fits properly at the center of the edge of the body centered unit cell, body-centered cubic unit cell. In body-centered cubic unit cell, particles at the corners are not in actual contact. So, you can place another sphere over here. What you want to find out is radius of this sphere. That means, what will be the diameter of that sphere? Diameter means this much distance. What about that distance? You know, edge length is A. If you take edge length as A, and these two are the two radius over here, A minus 2R will give you the diameter of the sphere that you can place in that gap. Clear? So, you want to find out A minus 2R. Clear? How will you find out A minus 2R here? What is the relation in body-centered cubic? A root 3 equal to 4R. Isn't it? A root 3 equal to 4R means what will be 2R? 2R is equal to A root 3 by 2. Am I right? A root 3 by 2. So, you can place A minus, what is 2R here? 2R is the diameter of the sphere that you are going to place. Clear now? But I will repeat all these questions. I will repeat this question. I hope you are all following. Are you following this question? What about this? Radius of the largest sphere, that which fits, you want to place the sphere, largest sphere, where you want to place, you are given with a body-centered cubic arrangement. Clear now? You are given with a body-centered cubic arrangement. Okay. Here you are placing another sphere. You know, the sphere that forms body-centered cubic is like this. These spheres are in contact with a particle in the body center. I hope you are all following, right? So, you can see how to find out this distance. I will repeat. Suppose the edge length is A. This edge length is A. A minus these two. This is the radius of the sphere that forms BCC. So, A minus 2R will give you diameter of the sphere that you can place in this gap. Clear? So, A minus 2R. How is related 2R and A? You know, for a BCC, A root 3 equal to 4R. Isn't it? For a BCC, you can say, if you take the body diagonal, there will be 4R. Clear? So, A root 3 equal to 2 times 2R. Am I right? So, what is this 2R? 2R is A root 3 by 2. So, A minus A root 3 by 2. That is what you want to find out, and you want to find out the radius also. You just take the half of it. Clear now? Now, how will you do it? You take A outside. You can say A into 1 minus 1.73 by 2. That is A into 1 minus 0. What about it? Nearly 0.86. Okay. That is A into 1 minus 0.86. You can take it as 0.14, right? 0.14 nearly. So, what is the radius of the sphere you can place? This is the diameter. You take the half of it. So, probably what will be the answer? 0.067 A. I hope you got the answer as D. Anupama, you got the answer as B. That B stands for what? Diameter of the sphere. What you want to find out is what? Radius of the largest sphere. So, you will get what? You will get 0.067 A. Aishwarya, you got it? The question, already you reported the answer as B. That stands for what? Diameter of the sphere you can place there. Clear? Let me go to the next one. What about question number 44? Come on. An element crystallizes in the structure having FCC unit cell. If 200 gram of this element contain 24 into 10 to the power of 23 atoms, then its density is. How will you find out density? Come on. Density, you know D equal to what? Zm by A cube into Avogadro number. Please put Z. What is Z here? They say FCC, face-centered cubic. What is the rank of it? In FCC, you know the rank is 4. There are 4 particles. How do you got that 4 particle? 1 by 8 into 8 plus half into 6. So, 4 into, what is the molar mass here? Okay, what you want to find out is, you want to find out density, but the idea is molar mass is not given. Instead, they say 24 into 10 to the power of 23 atoms weighs 200 gram. So, let me modify the same result. You are familiar with this result, am I right? D equal to Zm by A cube into Avogadro number, you know. If you take Avogadro number atoms, its mass is m, molar mass. If you take n atoms, its mass is 200 gram. So I rearrange this result. D equal to Zw by A cube into n. Please don't forget, this n is not Avogadro number, but the W is the mass of this n atoms. Okay, you can write D equal to either Zm by A cube into Avogadro number, or you can write D equal to Zw by A cube into n. So I am using this result here. What is Z here? FCC 4. W is given as 200. A cube, what about A cube? 200 picometer. Picometer means, you know, 10 raised to minus 12 meter. But I am taking here 10 to the power of minus 10 centimeter. Why? Because all the answer is given is gram per cm cube. So 4 into 200 divided by 200 into 10 to the power of minus 10 cube into Avogadro, and don't take Avogadro number, that number given is 24 into 10 to the power of 23. Am I right? Now 4 into 200 divided by, you can take this as what? These two zeros can be given to 10 to the power of minus 10, so it becomes 10 to the power of minus 8. So you can write here as 10 to the power of minus 8. So what will be 2 cube? 8. 10 to the power of minus 8 cube? 10 to the power of minus 24. Into 24 into 10 to the power of 23. Am I right? So you can write it as, you can cancel here. So you can also cancel this part here. So 100 divided by, what remains here? 24 into 10 to the power of minus 1. I hope I am right, isn't it? So 1000 divided by 24. 1000 divided by 24 means nearly what? 1000 by 25 is 40. So it should be 41.66. Isn't it? But you know that this is a hypothetical question. No element has such a density in Earth. Isn't it? Let me go to question number 45. What about question number 45? What do you want to find out? The structure of the unit cell. So what is your idea? If you find Z and if you got Z as 1, you will say it is simple cubic. If Z equal to 2, you will say BCC. If Z equal to 4, you will say FCC. Isn't it? So you want to find out Z here. You know D equal to what? Zm by A cube into Avogadro number, right? What is Z here? That is to be determined. What is M? Aluminium. What about atomic mass? 27 divided by A cube. A cube is what? 405 into 10 to the power of minus 10 centimeter. That cube into Avogadro number 6.02. You can take it as 6. 6 into 10 to the power of 23. This should give you what? 2.7. How will you find out Z here? Z equal to, you can cancel here as what? 10 times. Am I right? So 10 Z is equal to what? You can think in this way. What about 405? You can take it as 4.05 into 10 to the power of minus 8. Okay. If so, what will be 4 cube? 64. So I take it that side. 64 into 10 to the power of minus 24 into 6 into 10 to the power of 23 divided by 10. Clear now? So what will be this? This year you can cancel by how much? You can keep the 10 as such. Now you can see here it is what? 10 raised to minus 1. So you can say 64 into 6 divided by 100 approx. I took the 10 raised to minus 1 in the denominator so that 10 into 10 become 100. So here 64 into 6 by 100. 64 into 6. 64 into 6 means nearly 380, isn't it? Divided by 100 means 3.8 for nearly. 3.8 nearly approximated to 4. Why? You have to get either 1 or 2 or 4, isn't it? It should be whole number. So the set should be equal to 4. Then you can say it is face-ended cubic unit cell. Even without all this, you can say aluminum is FCC pattern, isn't it? Now let me go to question number 46. What about question number 46? Density of a metal which crystallizes in BCC. What is Z? Z is 2. BCC means Z is 2. What is edge length? 300 picometer, or you can say 3 into 10 to the power of 300 into 10 to the power of minus 10. So 3 into 10 to the power of minus 8 centimeter. What do you want to find out? You want to find out density. Directly put D equal to Zm by A cube into Avogadro number. What is Z here? BCC means Z is 2. M is what? 27. What about A cube? A cube is 3 into 10 to the power of minus 8 cube. What about Avogadro number? You know, 6 into 10 to the power of 23. What about M here? M is not 27. M is given as 50 here. I'm sorry. So, you can write it as what? 100 divided by 3 cube is 27. 10 to the power of minus, am I right? 10 to the power of minus 24 into 6 into 10 to the power of 23. Here you can take 10 to the power of minus 1, that you can take in the numerator. So I think nearly 1000 divided by 27 into 6. Do you agree with me? Do you got that answer? How much you got? 27 into 6 here. 6 sevens are 42. And what about here? Nearly 162. So anyway, the answer should start with the 6. There is only one answer starting with the 6. Okay, good. So the answer is C, I think. Anybody? I hope some of you reported the answer as B is wrong. I think the correct answer is option C, right? Clear now? Okay. What about question number 47? How will you do this question number 47? What do you want to find out? You want to find out cell lead G equal to 600 picometer, the number of atoms in 100 gram. I told you what is D? D equal to ZW by A cube into Avogadro number. Okay. You know that D equal to Zm by A cube into Avogadro number. But let me rearrange that may be modified. You know what is this M? Molar mass. That is mass of Avogadro number particle. If you write it in this way, D equal to ZW by A cube into N, where N is the number of particles. What you want to find out is number of particles here. So, number of particles is equal to ZW divided by A cube into D. What is Z here? FCC. FCC means Z is 4. What is W given? W given is 100 gram. What is A cube? 100 picometer. 100 into 10 to the power of minus 10 centimeter. Its cube. What is D? Density is given as 10. So 4 into 100 divided by, you can take these two zeros over here. It becomes 10 to the power of minus 8. 10 raised to minus 8 cube is 10 to the power of minus 24 into 10 here. Okay. So you can cancel 10 over here. So 40 into 10 to the power of 24. 40 into 10 to the power of 24 means 4 into 10 to the power of 25. Very good. Many of you got that answer. Question number 48. What about question number 48? A metal has FCC lattice. What about Z? FCC. Immediately you can write Z equal to 4. What about edge length? Edge length is 404 picometer. Density of the metal. What is given? 2.72 gram per cm cube. What do you want to find out? Molar mass. How will you find out? D equal to Zm by A cube into Avogadro number. What you want to find out is molar mass. Molar mass is D into A cube into Avogadro number by Z. What is density here? 2.72. What is A? 404 picometer. How will you write? 4.04 into 10 to the power of minus 8. Its cube into 6 into 10 to the power of 23 divided by, what is Z here? FCC. FCC means what? FCC equal to FCC Z equal to 4. Isn't it? That on solving you will get M. Do you got it? How much you got? Kavya reported the answer as C. Do you agree with it? Is it C? 2.72 into 4 cube is 64. 10 to the power of minus 24 into 10 to the power of 23 into 6 divided by 4. 4 you can cancel over here. 16. Then how much you got? 2.72. Anybody? 2.72 into 16 into 6 into 10 to the power of minus 1. Anyone? 16, 6 you can take it as 96. So it can be taken as 272 by 10. That is 27.2. Probable answer is option A. Good. Okay. I hope you got it. You are all following. ഇത്ര ബുദ്ധിമുട്ടുണ്ടോ അത്? നമുക്ക് വേഗം പറഞ്ഞു പോവാലോ. ഇതിൽ എന്താ വെച്ചാൽ എല്ലാവർക്കും മനസ്സിലാവുന്നുണ്ടോ അത്? എന്തായാലും യു ആർ ഗോയിങ് ടു റീഡ് ദ ക്വസ്റ്റ്യൻസ് ഇൻ ഇംഗ്ലീഷ്, റൈറ്റ്? അപ്പോൾ നമുക്കത് ഇംഗ്ലീഷിൽ തന്നെ പറയുമ്പോൾ നിങ്ങൾക്ക് അത് വേഗം യൂസ്ഫുൾ ആവുമെന്നാണ് എനിക്ക് തോന്നുന്നത്. Clear now? Okay ആണോ എല്ലാവരും? ഹാപ്പി ആണോ? അടുത്തിലേക്ക് പോയിക്കോട്ടെ. വേഗം വേഗം പോകാൻ നമുക്ക് എപ്പോഴും നല്ലത് ഇംഗ്ലീഷിൽ റീഡ് ചെയ്ത് പോകുന്നതായിരിക്കും. Clear? Let me go to question number 49. Okay, question number 49. What do you want to find out here? How many lithium atoms are present in a unit cell with edge length 3.5 angstrom and density 0.53 gram per cm cube? Please don't forget, nobody will going to explain the questions in the exam hall. At the moment you see the question, you should get that idea. Clear now? How many lithium atoms are present in a unit cell with the edge length is 3.5 angstrom? What do you want to find out? How many lithium atoms in unit cell? What it conveys? Z equal to what? Right? Z equal to what? What you want to find out is Z. Even without doing this, you know all alkali metal will crystallizes in BCC because we have already done S block element. Already 100 question series based on S block element is also over. So all alkali metal crystallizes in BCC, you know. So Z is 2. Or you can do it. How will you do it? D equal to Zm by A cube into Avogadro number. What is that? Z equal to D into A cube into Avogadro number by M. What is density? 0.53. What is edge length cube? 3.5 angstrom. Here it is in centimeter cube. So 3.5 into 10 to the power of minus 10 meter, or you can say 3.5 into 10 to the power of minus 7 centimeter. Clear? Its cube into Avogadro number 6 into 10 to the power of 23. What is molar mass? Lithium. You can take it as 7. You can do it. How? 0.53 into 3.5 into 3.5 square. Am I right? 6 into 10 to the power of 23 into 10 to the power of minus 21 divided by 7. 7 I can cancel here so that it become 0.5. All of you know 35 square is 1225. Am I right? 35 into 35, you know it. All of you know the squares up to 40, I know. So 3.5 square is what? 12.25 you can take. So 0.53 into 0.5 into 12.25 into 6 into, what about it? 6 into 10 to the power of what? 10 square. 6 into 10 square. Do you agree with me? Okay, this much you want to find out. 0.5 into 6 is what? 3. So 3 into 0.53 into, how much I got? 10 square is obtained. What about the power of 10? Is there any problem with the power of 10 here? Any problem with the power of 10? So can you do it? I think the answer you want to get it as 2. Do you got it? I think I made a mistake over the power of 10. How will you do it? D equal to Zm by A cube into Avogadro number. You want to find out Z. Z equal to D. What is D here? 0.53. A cube. What is A cube? 3.5 into 10 to the power of minus 7 cube. Am I right? 3.7 into 10 to the power of, no, it's 10 to the power of minus 8. Am I right? 3.85 into 10 to the power of minus 8. I made a mistake over there. Into Avogadro number 6 into 10 to the power of 23 divided by molar mass. Molar mass is taken as 7. So 0.53 into 3.5 into 3.5 square into 10 to the power of minus 24 into 6 into 10 raised to 23 divided by 7. Clear now? Here I can cancel. So 0.5. 0.5 I can cancel over here 3. So it become 0.53 into 3.5 square is 12.25 into 3 into 10 to the power of minus 1. Clear now? So this on solving, how much you got? That is 36.36, half of it 18. So nearly 1.9 something I got. That means 2. Z is 2. That means BCC. Clear? Now coming to question number 50. How much question here? Density of edge length of values. Hello, you are all following, right? Density of edge length of values for a crystalline element with FCC lattices are 10 gram per cm cube and 400 pm respectively. number of unit cell in 32 gram of the crystal is? How will you do it? Density of edge length values of crystalline element with FCC 10 gram per cm cube and 400 picometer respectively. Number of unit cell in 32 gram of this crystal. What is the logic? You are given with the 32 gram. First you want to find out, actually number of unit cell you want to find out. Or you can do in this way also. We know D equal to Zm by A cube into Avogadro number. So that. Or you can say D equal to what? D equal to ZW by A cube into N. What? Where N is what? Number of atoms present in the 32 gram elements. So N is equal to Z. What is Z here? FCC. Z is 4. W. How much gram you took? 32. Divided by A cube. What about edge length? 400 into 10 to the power of minus 10. Why I am taking 10 raised to minus 10? Because I want to get it in centimeter cube. So Avogadro number 6 into 10 to the power of 23. This on solving you will get the number. Please don't forget what is asked, not the number of atoms, but instead number of unit cell. You know that 4 atoms can contribute to 1 unit cell. How do you know that? It is FCC. So divided by 4, you will get what? Number of unit cell. This is one idea, isn't it? Or you can omit this 4, you will automatically get number of unit cells, isn't it? That way also you can do it. So please do it. How much you got? 4 into 32 divided by 4. Here it is cube. 4 cube is 64. 10 to the power of minus 24. 6 into 10 to the power of 23. Clear now? So you can cancel here how much times? 16 times. Here you can cancel 2 times. So it is 1 by 3 approx. Clear now? So how much you got? Please do it. Number of unit cell can be obtained by 32 divided by, I am directly getting number of unit cell. 4 cube is 64. 10 to the power of minus 24. 6 into 10 to the power of 23. This you can take 10 raised to minus 1, that can be 320. Clear? So nearly how much you got? How much you got? What is number of unit cell you want to find out? Do you got the idea? Oh, here you want to find out. I put an Avogadro number here. Avogadro number is not there. Hello, you are attending. I made a mistake over here. I will do it again. What do you want to find out? Number of unit cells. First, I would like to find out the number of atoms. Clear? I made a mistake, Nandana. You want to find out the number of atoms first. How will you find out? I repeat, D equal to Zm by A cube into Avogadro number. I rearrange it as D equal to Zw by A cube into N, where N is the number of atoms. N equal to Zw by A cube into D. What is Z? FCC, Z is 4. What is W here? 32. What is A cube here? A is 400 picometer. 400 picometer means what? 400 into 10 to the power of minus 10 centimeter. Taking the cube, 4 cube is 64. 10 to the power of minus 8 cube. How do you got 10 raised to minus 8 there? This you can write it as 4 into 10 to the power of minus 8. So 4 cube into 10 to the power of minus 8 cube. That you can directly write 10 to the power of minus 24. Into D. What is D there? I want to put the D there. Instead I put Avogadro number. So how much you got? You can cancel. Here it is 16 times. Clear now? This is 2 times. So 2 into 10 to the power of minus 23 in the numerator, it becomes 10 to the power of 23. This is the number of atoms in it. But in order to get one unit cell, there should be 4 particles since it is FCC. So how many unit cells are there? 2 into 10 to the power of 23 divided by 4. That is 0.5 into 10 to the power of 23. 5 into 10 to the power of 22, I got it. Clear now? Okay, let me go to question number 51. How will you do this question number 51 here? I hope all of you are attending here. An element crystallizes in BCC, a cell edge 500 picometer, density 4 gram per cm cube. Atomic mass of the element you want to find out. How will you find out atomic mass? What is the given density? Please do it. D equal to Zm by A cube into Avogadro number. You want to find out M. M equal to D into A cube into Avogadro number by Z. What is D here? What is D here? D, density is given here as what? 4 gram per cm cube. What is A? Edge length is 500 picometer. So 500 into 10 to the power of minus 8 centimeter. Its cube. Into Avogadro number is 6 into 10 to the power of 23. What is Z? Body centered cubic. Z equal to 2. So you can write 4 into, you can take the 2 zeros here. You can take the 2 zeros. So it become what? 10 to the power of minus, 10 to the power of minus 10 centimeter. Taking the 2 0, it become 10 to the power of minus 8. Clear now? It become 5 cube into 10 to the power of minus 24 into 6 into 10 to the power of 23 by 2. Clear? So it become what? 2 into 125 into 6 into 10 to the power of minus 1. How much you got? 250 into 6 into 10 to the power of minus 1. 25 into 6, 150. Do you got D? Good. Now let me go to the next question. Question number 52. Please do it. Anu, what you? Idho Anu chodikkunnundallo. ഇതിന്റെ എല്ലാത്തിന്റെയും PDF കിട്ടാറില്ലേ? അനു എന്തൊക്കെയോ ചോദിക്കുന്നുണ്ട്. അനു എന്താ ഇത്രയൊക്കെ ചോദിക്കുന്നേ? ക്വസ്റ്റ്യൻ അനു ഇതിന്റെ ഒന്ന് ആൻസർ പറഞ്ഞേ. വാട്ട് അബൌട്ട് ക്വസ്റ്റ്യൻ നമ്പർ 52? Come on. In 52 what you can say? Missing or misplacement? Misplacement. Which is misplaced? One of the cation is misplaced from the lattice site to interstitial space. Instead of occupying in the lattice site, cation entering into the interstitial space. This type of defect is called what? This type of defect is called Frankel defect. Isn't it? Now let me go to 53. What about 53? Frankel defect and density. You know nothing will happen to the density. Why? There is no missing of particles. Only misplacement. So the crystal density remains as such. Nothing will happen to the density of the crystal. You know, during Schottky defect, density of the crystal is lowered. But in Frankel defect, nothing will happen to the density. Coming to question number 54. Alkali metal halides do not show Frankel defect. You know, alkali metal cations are larger cations. Big cations. These cations cannot enter in the interstitial space. So, large cation cannot be accommodated in the interstitial space. So, we can say, or you can say, cations and anions have almost similar size. So the void made by the anions cannot enter, cannot occupy these cations there. Clear? So anions and cations are almost similar in size. So we can say cations and anions have almost equal size. In that case, you can expect Schottky defect, not the Frankel defect. Clear now? Don't take the answer as B. They say large difference in size of cation and anions that favor which defect? That will favor the Frankel defect. Okay, anions are occupying in the lattice, cations entering in the lattice side, interstitial space of that lattice. Clear? That is Frankel defect. So in order to occupy cation in the interstitial space, cation should be small. Clear? Coming to question number 55. Crystal does not exhibit Frankel defect. I told you alkali metal halides will never show Frankel defect because alkali metal cations are large cations. Question number 56. What about zinc blend? Zinc blend possesses coordination 4-4. Low coordination crystal generally show which defect? Frankel defect. So Frankel defect is shown by zinc blend. Generally, crystals having low coordination number will show Frankel defect. Now coming to question number 57. In a Schottky defect, you know what about Schottky defect? There will be missing of equal number of cations and anions so that vacancies are created. So what will be the correct answer? Some lattice sites are vacant. Cation vacancy and anion vacancies are there in Schottky defect. Clear now? Let me go to the next one. Question number 58. Same thing. You can see the missing of Na plus and Cl minus there. Na plus, Cl minus, etc. are missed. That means which type of defect? Schottky defect. Equal number of cation and anions are missed. Coming to question number 59. Electron trapped in the lattice site are called what? F sender. Why they are called F sender? F comes from the word Fabe. Fabe means what? Color. Because they can impart color to the crystal. Isn't it? Clear now? Question number 60. Which will have metal deficiency defects? Metal deficiency defects are shown by transition metal compound. Why? They can show variable oxidation state. Transition metal compounds can easily show metal deficiency defect because they can show what? They can show variable oxidation state. Suppose in an iron oxide, if one of the Fe2 plus is missed, what will that do? One of the Fe2 plus is missed, neighboring Fe2 plus will form higher oxidation state, Fe3 plus, in order to maintain the electric neutrality. Isn't it? Coming to question number 61. M.98O. M present M2 plus and M3 plus. Fraction of metal which exists as M3 plus. What is the shortcut you know? You can write this as M98O100. So you can write M3 plus. Number of M3 plus in it is 100 minus 98 into 2. Isn't it? That means 2 into 2. There are 4 M3 plus out of 98 M. Isn't it? So 4 M3 plus out of 98 M. So you can say what is the fraction 4 by 98? How much percentage M3 plus? 4.08%. Clear? Or you can do the same question based on electrical neutrality. How will you do that? You can do the same question in this way also. That is M98O100. You just assume that there are X M3 plus. So how many M2 plus will be there? 98 minus X. O2 minus will be 100. How will you do? Then principle of electric neutrality. Electric neutrality, if you apply, what will be the total positive charge here? 3x plus 2 into 98 minus x equal to 200. How do you got that 200? Negative 2 into 100 means negative 200. So the total positive charge should be plus 200 to maintain electric neutrality. So the total positive charge should be positive 200. Or you can say 98 into 2, that is 196 minus 3x minus 2x is what? X. That should be equal to 200. So you can say x is equal to 4. Out of 98, 4 M3 plus is there. So 4 by 98 into 100. That will be gives 4.08. Or you can do in a direct way also. Isn't it? Let me go to the next question. What about question number 62? Same type. Can you guess the answer? They say it is A.8O. Question asked is fraction of A2 positive ions in it. How will you do it? You can think in this way, A8O10. Or you can take in a better way, A80O100. You can write that way also. Isn't it? Then how will you find out A3 plus in it? A3 plus in it is equal to 100 minus 80 and take the double of it. That is 20 into 2, that is 40. A3 plus present is 40. Out of 80, there is 40 A3 plus. That means 40 A3 plus, 40 A2 plus. That means 0.5 fraction. Clear? Hello, you are all following? How many of you are in need of Malayalam? I think you are all following. I found that some candidates are outside Kerala also. Only a few. Still, I would like to say, but Malayalam is not needed. I told you earlier, you are all going to write the questions in English, isn't it? That's why I am following in this way. Do you agree with me? Okay. Right. So, you can do this question in a little different way also. If you want to do it in this way, you can write A 8 O 10. Apply principle of neutrality. A 2 plus x times A 3 plus 8 minus x. O 2 minus 10. Apply principle of neutrality. Total positive charge should be equal to total negative charge. That means 2x plus 3 times 8 minus x should give you 20. How do you got it? Minus 2 into 10 is minus 20. So, sum of all these positive charge should give you plus 20. So, you can say 2x plus 24 minus 3x equal to 20. Clear? 24 minus x is equal to 20. So, x is equal to what? X is equal to 4. Out of 8, 4 is A2 plus. So, A3 plus is also 4. Clear now? Okay. Let me go to question number 63. Come on, try to do this question. How will you do it? Nickel 0.98O. How will you write? Nickel 98O 100. What about Ni3 plus in it? 100 minus 98 into 2. That is 4. What do you want to find out? Ni2 plus ions. That out of 98 nickel, 94 is Ni2 plus and 4 is Ni3 plus. Clear now? So 94 into 98. Even without solving, you can say as correct answer is option A. Clear now? Question number 64. What about question number 64? Mark the incorrect pair. Incorrect pair ഒന്ന് കണ്ടുപിടിക്കാവോ? ആദിത്യനൊന്നും മനസ്സിലാവണില്ലേ? ആദിത്യന് മനസ്സിലാവണുണ്ടോ? Question number 64. Incorrect pair. What about incorrect pair? Schottky defect. Is it correct or not? Equal number of cation and anion missing. That is Schottky defect. Frankel defect. What about Frankel defect? A cation from the lattice site will enter in the interstitial space. Lattice site il irikenda cation evada keriyirikum? Interstitial space il irikum. So, dislocation of cation from normal site to interstitial site. Impurity defect. Suppose AgCl crystal. Suppose you are taking AgCl crystal is doped with what? AgCl crystal is doped with cadmium ion. AgCl crystal is doped with cadmium ion. എന്ത് വരും പറഞ്ഞേ? Suppose you are doping cadmium chloride. Ag plus ion replaced with cadmium ion. So what will happen? One of the cation is also missed. രണ്ട് Ag plus പോയാൽ ആര് വരും? ഒരു cadmium ion വരും. ശരിയല്ലേ? അപ്പോൾ ഏതാണ്? impurity defect വരുമ്പോൾ എന്തുണ്ടാവുക? Cation vacancy. Why cation vacancies are created? In order to incorporate one Cd2 plus ion, you want to remove 2 Ag plus ion. You are removing 2 Ag plus and putting one Cd2 plus. So automatically there will be one cation vacancy. This is metal excess or metal deficiency defect. This is metal deficiency defect. Strictly, you know, in Fe2 plus and O2 minus, for 100 oxide, there should be what? 100 Fe2 plus. But in this case, 93 iron is present. So, metal deficiency defect. Metal is present in less amount. So, metal excess is wrong. It is metal deficiency defect. So, that will be the incorrect statement. Aditya മനസ്സിലായോ? Let me go to the next one. What about question number 65? How will you find out question number 65 here? Conductors. The range is correct. You should by heart it. Insulators. This is wrong. This is the range of semiconductors. Semiconductors. This range is also wrong. This is for insulators. So, these are given in ulta order. So, one is correct. What is one to find out? Correct. Only one is correct. Other two are inverted. Let me go to question number 66. What about question number 66? N-type semiconductor. Germanium should be doped. Aditya, you know What about germanium? Carbon, silicon, germanium, etc. are which group? Group 14 elements. So what? There should be 4 valence electron in it. They are group 14 element. So in group 14 element means there are 4 valence electrons surrounding the germanium. Right? So each germanium obtained octet by the neighboring germanium atom. You know that each germanium will complete its octet from the neighboring germanium atom like this. Isn't it? This is the pure germanium crystal. But if you dope using which one? Suppose you are doping pentavalent atom, say group 15 elements like phosphorus, arsenic, antimony, bismuth, etc. They are pentavalent atom. Pentavalent atom means their valence shell contain how many atoms? How many electrons? 5 electrons. Suppose you are doping a pentavalent atom here. You are doping a pentavalent atom like arsenic. You know there are 5 valence electrons. 1, 2, 3, 4, 5. Then there is an electron, excess electron in it. So we call the pentavalent atoms as donor atoms. So you can see that lot of electrons will be there in the conduction band. Isn't it? The number of electrons in the conduction band become greater than number of holes in the valence band. Why? The pentavalent atom donated that electron. So pentavalent atoms are donated or doped in the crystal lattice of group 14. You will get what? You will get a N-type semiconductor. Clear? Clear now? Suppose you are doping a trivalent impurity. What will happen? Suppose you are taking silicon. Silicon, you know, group 14. So the valence electron is 4. 4 valence electrons are there. Silicon the valence shell 4 electrons ഉണ്ട്. So എന്താണ്ടാവുക? ഓരോ സിലിക്കണും അവൻ്റെ ഓക്ടറ്റ് ഇങ്ങനെ കംപ്ലീറ്റ് ചെയ്തിരിക്കുന്നുണ്ടാവും. Isn't it? Now you are doping what? Group 13 element. അപ്പോൾ group 13 element ഡോപ്പ് ചെയ്താൽ എന്താണ്ടാവുക അവിടെ? Suppose you are doping a group 13 element. ഇവിടെ 13 element. Its valence electron contain what? 3 electrons only. അപ്പോൾ അവന് പഴയ പോലെ ഓക്ടറ്റ് കംപ്ലീറ്റ് ആവുമോ? ഇല്ല. അപ്പോൾ എന്ത് വരും? ഒരു ഹോൾ വരും അവിടെ. There will be a positive charged hole in the valence band. Clear now? So you will get P-type semiconductor. Coming to question number 68. Paramagnetic substances. They contain one or more unpaired electrons and they are attracted towards magnetic field. Question number 69. Paramagnetic substances on heating 850 Kelvin. Beyond the Curie temperature, it become what? It become paramagnetic. Question number 70. Antiferromagnetic. Oxides of manganese are antiferromagnetic. You know it, isn't it? Antiferromagnetic. NO2 should be what? Paramagnetic because it is an odd electron species. MnO2, oxides of manganese are antiferromagnetic. Question number 71. What about ferrimagnetism? You know that in ferrimagnetism, magnetic domains are arranged in opposite direction in unequal numbers. Aligned in parallel and anti-parallel in unequal numbers. If they are in equal numbers, you will say it as antiferro. Isn't that? Coming to question number 72. Ferromagnetic. All the magnetic domains aligned in the same way. Ferrimagnetic. Aligned in opposite direction in unequal numbers. So A3, B1, correct option goes to option A. Question number 73. Density of pure substance A whose atoms pack in cubic pack arrangement is 1 gram per cc. If B atoms can occupy tetrahedral void without distortion and they occupy all the tetrahedral voids, then what is the density of resulting solids in gram per cc? കണ്ടുപിടിക്കാവോ? How will you do it? Density of pure substance A എത്രയാണ്? Whose atoms pack in cubic closed pack arrangement is 1 gram per cc. ഞാൻ ഇതുവരെ പറഞ്ഞതിൽ ഏതെങ്കിലും മലയാളത്തിൽ പറയേണ്ട ചോദ്യങ്ങൾ ഉണ്ടായി എന്ന് എനിക്ക് തോന്നുന്നില്ല. ഏതെങ്കിലും മലയാളത്തിൽ പറയേണ്ടി വന്ന ചോദ്യം ഉണ്ടെങ്കിൽ പറയുവാണെങ്കിൽ നമുക്കത് പിന്നെയും ഡിസ്കസ് ചെയ്യാം കേട്ടോ. നിങ്ങൾ എന്തായാലും അത് മനസ്സിലാക്കണം എന്നുള്ളതാണ് ഇമ്പോർട്ടൻറ്റ്. നിങ്ങളത് കറക്റ്റ് മനസ്സിലാക്കി പോകണം എന്നുള്ളതാണ് ഇമ്പോർട്ടൻറ്റ്. പിന്നെ ഫാസ്റ്റായിട്ട് പോകാൻ നമുക്ക് ഇംഗ്ലീഷിൽ തന്നെ ഇങ്ങനെ വായിച്ച് പോകുമ്പോൾ വേഗം പറ്റും. അപ്പം നിങ്ങൾ ക്വസ്റ്റ്യനും അങ്ങനെ തന്നെ പ്രാക്ടീസ് ചെയ്യണം. ക്വസ്റ്റ്യൻ ഡിസ്പ്ലേ ചെയ്യുന്ന സമയത്ത് തന്നെ അത് വേഗം പോകണം. ഓക്കെ, ക്വസ്റ്റ്യൻ നമ്പർ 73 പോകാം. ക്വസ്റ്റ്യൻ നമ്പർ 73 എന്താ? നന്ദന എന്താ 1 gram per cc എന്നൊക്കെ അടിച്ചു വെച്ചിരിക്കുന്നത്? ഒന്ന് നോക്കിയേ, ക്വസ്റ്റ്യൻ ഒന്ന് ചെയ്തു നോക്കിയേ. Density of a pure substance A whose atom pack in cubic closed pack arrangement is 1 gram per cc. If B atoms occupy the tetrahedral void without distortion, they occupy all the tetrahedral voids, then what is the density of the resulting solid in gram per cc? This is the question. എങ്ങനെ പറയും? നമ്മുടെ കയ്യിൽ എന്താ ഉള്ളത്? 1 gram per cc ഡെൻസിറ്റി ഉണ്ട് അല്ലേ? Let me write 1 cm cube contain 1 gram A. Originally 1 gram A is there. Now I am placing what B into the tetrahedral void without distorting the crystal. ഞാൻ tetrahedral voids are filled with B. Okay, without distortion. Clear now? അപ്പോൾ വോളിയം ഒരു cm cube തന്നെ നിങ്ങൾ എടുത്തു. 1 cm cube 1 gram A ഉണ്ട്. How many mole A is there? You know, the number of moles of A is 1 divided by its molar mass is 30. So 1 by 30 mole A is there in 1 cm cube. Clear? Can you say how many tetrahedral voids are there? You know that number of tetrahedral void is double the number of spheres. Here 1 by 30 mole A is present. So how many tetrahedral voids will be there? 2 by 30 mole tetrahedral void will be there. 2 by 30 mole tetrahedral void will be in that 1 cm cube. Do you agree with me? In 1 cm cube crystal, if you take 1 cm cube means you are actually taking 1 by 30 mole A, in which 2 by 30 mole tetrahedral void will be there because number of tetrahedral void is always double the number of spheres. In all these tetrahedral voids, you place what? B. Isn't it? So how many mole B is placed? 2 by 30 mole B is placed. So in 1 cm cube, you can see in 1 cm cube, let me write. 1 cm cube crystal now contain 1 gram A and 2 by 30 mole B. 1 gram A means what? 1 by 30 mole A, isn't it? That is 1 by 30 mole A and 2 by 30 mole B is present in that 1 cm cube. How much gram is there? 1 by 30 mole A means 1 by 30 into its molar mass is 30. That you know 1 gram. Divided 2 divided by 30 into what is the molar mass of B? That is 50. This much gram present in 1 cm cube. So what is the new density? Total mass by total volume. What is total mass here? 1 gram A and 100 by 30 gram B. Isn't it? That means what? 1 into 3, 3 plus 10 by 3, right? That is 13 by 3 gram per cm cube. 13 by 3 gram per cm cube means what? 4.333, isn't it? So the correct answer is A. I hope all of you got it. എല്ലാവർക്കും മനസ്സിലായോ? ക്വസ്റ്റ്യൻ ചെയ്തത് എങ്ങനെയാണെന്ന് ഒന്നുകൂടി റിപ്പീറ്റ് ചെയ്യണോ? വേണ്ടല്ലോ. Let me go to the next one. Question number 74. What about question number 74? A mineral having the formula AB2 crystallizes in cubic closed packed lattice with the A atoms occupy the lattice points. The coordination number of A atoms, that of B atoms, and the fraction of. Simple question. See, AB2 means what? 1A, 2B. Clearly, you know, A is in FCC. If you take 1 mole A, there should be 2 mole tetrahedral void, isn't it? So B should be arranged where? In tetrahedral void. Clear? So this type of arrangement is almost like calcium fluoride. They are called fluorite structure. So A is in FCC And B particles are present where? B particles are present in all tetrahedral void. എങ്ങനെയാ മനസ്സിലായത്? If one mole particle is arranged, there will be 2 mole tetrahedral voids. Clear? So AB2. And again, you know, in calcium fluoride, 1 calcium surrounded by 8 fluoride. Same way, 1 A surrounded by 8 B particle. And also 1 B surrounded by 4 A particles. So the coordination number of A is 8 and that of B is 4. So 8-4 coordination, 100% tetrahedral site is occupied. Then only you will get AB2. Clear? AB2 type means A particles are arranged, B particle present in all tetrahedral voids. Now let me go to question number 75. What about question number 75? Atoms of element Y form CCP. There are some harder questions. അവസാനത്തേക്ക് കുറച്ച് ടഫായ ക്വസ്റ്റ്യൻ ഉണ്ട്. വേഗം പോവാം നമുക്ക്. Atoms of elements Y form CCP. Y CCP ലാണ്. Suppose you are taking 1 mole Y. എപ്പോഴും അങ്ങനെയല്ലേ? Y is taken as 1 mole. എന്തെങ്കിലും arrangementil എന്താണെന്ന് പറഞ്ഞോ, you should take it as 1 mole. Y is in CCP arrangement. Immediately you should take it as 1 mole. So how many tetrahedral voids will be there? Tetrahedral void will be double the number of spheres. So you can take it as 2 mole. How many X occupies? 2/3 of 2 mole. That means 4/3 mole X is present. So X is 4/3, Y is 1. X4, Y3 is the answer. Clear? Coming to question number 76. What about question number 76? Oxide ions are arranged in CCP. Cations A occupy in 1/1/6 of tetrahedral void and cations B occupy 1/3 of octahedral void. The formula of the compound. Again, you will take what? Oxide ions are in CCP. Immediately you take oxide ion 1 mole. Where is this A occupy? 1/6 of tetrahedral void. How many tetrahedral void will be there? 2 mole tetrahedral void is there, out of which 1/6 is occupied by A. Then where is this B occupies? Octahedral void. How many octahedral voids are there? 1 mole octahedral void. How much part is occupied in it? 1/3 is occupied in it. So you can say A, how much? A 1/3, B 1/3, O1. Multiplying with 3, you can write AbO3. Clear now? Let me go to question number 77. Simple one. Again we are coming to a simple question. Length of body diagonal in FCC unit cell is A angstrom. But they are cheating. So that generally we will take edge length as A. But here they put that length of the body diagonal of FCC pattern is A√3. Clear? A√3 is what? Body diagonal. Body diagonal means what? A√3. Actually, if X is the edge length, body diagonal is X√3. This X√3 is given as A. X√3 is given as what? A. Where X is actually what? Edge length. Conventionally, we will take A as the edge length, but here X is taken as edge length and A is taken as body diagonal. What do you want to find out? Distance between 2 octahedral voids. You know that in FCC arrangement, the octahedral sites are edge center and in the body center. So that edge center and body center is the octahedral sites. Edge centers and also in the body center. You know the closest octahedral site is where? Closest means from the edge center to the body center. That is the closest approach. Isn't it? What you want to find out is distance between 2 octahedral voids. Nearest octahedral voids. Nearest octahedral voids are not from edge center to edge center. Instead, it is from edge center to body center. You know, from the length from edge center to body center is equal to what? If you take a face diagonal, you know it is A√2. So half of it you will get what? Edge center to body center. So what you want to find out is X√2 divided by 2. Where X is what? X is edge length. Clear? But answer is given in terms of A. So what will you do? What you want to find out is X by √2, right? You want to find out x by root 2. But what is this x? X equal to a by root 3. So a by root 3, already root 2 is there. So a by root 6 is our answer. How many of you got that answer? Clear now? Question seems to be simple, but they put, instead of edge length as a, they put body diagonal as a. Clear now? Let me go to the next one. What about question number 78? Can you do it? Shortest distance between an octahedral and tetrahedral void in FCC. Metallic lattice in terms of radius of FCC packed atom would be. The shortest distance between an octahedral void and a tetrahedral void. We know that in an FCC crystal, the octahedral void means what? Edge center and in the body center. Isn't it? Edge center and in the body center stands for the octahedral sites. So this is an octahedral site. Where is this tetrahedral void? I told you, if you take this cube as a 8 simple cube, if you divide this unit cell into 8 small cubes, and if you take center of each small cube, that stands for tetrahedral void. So what you want to find out is the distance from tetrahedral void to this octahedral void. That is what? If you take a corner to body center means what? The half of body diagonal. And if you take further half of it, you will get what? Tetrahedral to octahedral distance. So tetrahedral to octahedral distance means a root 3 by 4. Clear? A root 3 by 4 you want to find out. But instead of a, they give you what? Radius r. How can you relate r and a in FCC pattern? You know that a root 2 equal to 4r for FCC. A root 2 equal to 4r. So what will be a here? A is equal to what? 4r by root 2. You can write that way. So a is equal to 4r by root 2 here. Please put it here. A is 4r by root 2 into root 3 by 4. So r into root of 3 by 2. Okay, obtained? Clear now? Let me go to question number 79. How will you do it? മനസ്സിലായോ? ഏതെങ്കിലും ക്വസ്റ്റ്യൻ ഞാൻ ഏതെങ്കിലും പറയണമെന്നുണ്ടോ മലയാളത്തില്? നിങ്ങൾ തന്നെ ഒന്ന് ആലോചിച്ച് നോക്കൂ. കേട്ടിട്ട് മനസ്സിലാവാത്ത ക്വസ്റ്റ്യൻ ഏതെങ്കിലും ഉണ്ടായോ? ഇല്ലല്ലോ. Now let me go to question number 79. What about question number 79? How will you do it? Pycnometric density. How will you find out pycnometric density? Pycnometer എന്ന് പറയുന്നത് എങ്ങനെയാണ് നമ്മൾ കണ്ടുപിടിക്കുക അറിയോ? നമ്മളൊരു ലിക്വിഡ് എടുത്തു. ലിക്വിഡിനകത്ത് ഒരു ക്രിസ്റ്റലോ ഏതെങ്കിലും ഒരു ഓബ്ജക്റ്റ് ഇമ്മേഴ്സ് ചെയ്ത് വെച്ചു. ആ ലിക്വിഡ് ഡിസ്പ്ലേസ് ചെയ്ത വോള്യൂം നോക്കി. ആ വോള്യൂമാണ് ഈ ഓബ്ജക്റ്റിന്റെ വോള്യൂം. അങ്ങനെ വോള്യൂം കണ്ടുപിടിക്കുന്നതാണ് പൈക്കണോമീറ്റർ. അത് വെച്ച് ഡെൻസിറ്റി കാണുന്നതാണ് പൈക്കണോമെട്രിക് ഡെൻസിറ്റി. So in pycnometric density, we are actually finding the volume. In order to find pycnometric density, we are taking mass divided by volume. To determine the volume, എന്താ നമ്മൾ കാണുന്നത്? We are finding out the volume displaced by that object. Suppose a crystal is immersed in a suitable solvent. അപ്പോൾ എന്ത് വരും? There is a vacant space in it also. Clear അല്ലേ? Which question? Question number 78 once more. Let me explain question number 78 once again. What is given? Shortest distance between an octahedral and tetrahedral void. You know, octahedral and tetrahedral void you want to find out. You know where is this octahedral void situated? I told you edge center and in the body center. Suppose body center is octahedral site. Where is this tetrahedral void situated? You know tetrahedral void means എങ്ങനെയാണ് നമ്മൾ യൂണിറ്റ് സെൽ ഈസ് ഡിവൈഡഡ് ഇൻ ടു എക്സാക്ട്ലി 8 സിമ്പിൾ ക്യൂബ്സ്, റൈറ്റ്? 8 simple cubes. This big unit cell, or unit cell is not so big. Anyway, that unit cell is divided into 8 simple cubes. Okay. And if you take the center of each small cube, that site is tetrahedral void. This from tetrahedral site to octahedral site. You want to find out the distance between tetrahedral void to octahedral void. That distance means exactly half of the distance from corner to body center. Clear? Corner to body center, you know, body diagonal by 2. What is body diagonal? A root 3. A root 3 by 2 will give you what? From corner to body center. What do you want to find out? Tetrahedral site to body center. So what will be that? Half of it. So A root 3 by 2 by 2. Clear? So what you want to find out is A root 3 by 4 you want to find out. But you want to convert A in terms of R. This is an FCC system, right? In an FCC system, you know, particles in the corners, they are not in actual contact, but particles in the corners are in contact with the phase center particle. So in FCC system, you can say this length, that is phase diagonal. This phase diagonal is A root 2, that will be equal to 4R. A root 2 equal to 4R. So what is this A? A is 4R by root 2. What do you want to find out? A root 3 by 4. So A root 3 by 4, in which A can be substituted as 4R by root 2. Already there is root 3 and here is also 4. Cancelled. R into root of 3 by 2. Clear now? Let me go to the next one. So the answer obtained is option C, right? Okay. Fatima, you got it. Now let me go to question number 79. Question number 79 endana? How will you find out pyconometric density? Pyconometric density means mass divided by volume. How will you find out volume? നമ്മൾ ഒരു ലിക്വിഡിൽ ഇമേഴ്സ് ചെയ്തു. അപ്പോൾ അത് ഡിസ്പ്ലേസ് ചെയ്ത വോള്യൂമാണ് ഓബ്ജക്റ്റിന്റെ വോള്യൂം. ഓബ്ജക്റ്റിന്റെ വോള്യൂം എന്ന് പറയുന്നത് വോള്യൂം ഡിസ്പ്ലേസ്ഡ് ബൈ ദ വോള്യൂം ഓഫ് ദി ലിക്വിഡ് ഡിസ്പ്ലേസ്ഡ് ബൈ ഇറ്റ്. ക്ലിയർ? അപ്പോൾ അങ്ങനെയാണെങ്കിൽ how will you find out density? Density means mass of that crystal divided by volume. Here volume എന്ന് പറഞ്ഞാൽ ആരൊക്കെ ഉണ്ടാവും? ആക്ച്വലി ഒക്യുപ്പൈഡ് വോള്യൂമും ഉണ്ടാവും, ഓൾസോ വോയിഡിന്റെ വോള്യൂമും ഇൻക്ലൂഡഡ് ആണ്. സോ വോള്യൂം റിയലി ഒക്യുപ്പൈഡ് ഇൻ ഇറ്റ് പ്ലസ് വോള്യൂം ഓഫ് ദ വോയിഡ് ഓൾസോ. Isn't it? This is the total volume obtained by immersing this liquid. Crystal when dipped in liquid, some liquid is displaced by it. The volume of liquid displaced actually stands for the volume of that occupied lattice point and also unoccupied lattice point. So this density is given as 2.165 into 10 to the power of 3. Clear? Now X-ray density. X-ray density means what? Mass divided by volume really occupied in it. Clear? This is equal to 2.178 into 10 to the power of 3. Now dividing the two, you can see volume really occupied divided by volume occupied plus unoccupied. That means total volume. Total volume equal to 2.165 divided by 2.178. Clear now? What does this stands for? Occupied fraction. This is occupied fraction. What do you want to find out? Unoccupied fraction. How will you find out unoccupied fraction? Unoccupied fraction equal to 1 minus occupied fraction. 1 minus occupied fraction. If you solve it, you will get that answer. I hope you can do it. How will you do it? 2.178 minus 2.165. അപ്പോൾ 8 എത്രയാ കിട്ടുക പറയാവോ? 0.0. How much you got? 0.013 divided by 0.013 divided by 2.178. This on solving you will get what? 0.00 something you want to get. So the probable answer, can you guess what will be the probable answer? 1 0 പിന്നെ 1 പോയില്ല, പിന്നെ 0 13. How much you got? You please do it. Question number 80. Percentage of free space in the body centered cubic. Direct question. You know, in BCC 68% is occupied, 32% is vacant. Question number 81. Which of the following unit cell will have at least two lengths same, at least two angles same? In monoclinic, no sides are equal. In rhombohedral, orthorhombic, no sides are equal. Triclinic, no sides are equal. In rhombohedral, all sides are and all angles are equal. But no angles are equal to 90 degree. Okay. Before you got okay. Question number 82. What about question number 82 here? Come on, do it. Crystalline solid made XYZ. Atoms of X form FCC. So X is 1 mole if you take. Y occupy octahedral voids. How many octahedral voids will be there? 1 mole. Isn't it? While Z occupy tetrahedral voids. But question is not over. They say X is present in FCC. That means X present in all corners and in face centers. X is present in all corners and X is also present in the face centers, center of each faces. Isn't it? Y occupy all octahedral voids. Where is this Y situated? Y is in octahedral voids means Y is present in the edge centers, right? Edge centers and also in the body center. Z occupy in tetrahedral voids. A body diagonal, if you take a body diagonal, you just draw a body diagonal in this way. ഒരു ബോഡി ഡയഗണൽ ഇങ്ങനെ പാസ് ചെയ്യുന്നു. All the particles from the body diagonals are lost. What will be the simplest formula of the solid if atoms along any body one diagonal is removed? അപ്പോൾ how many X particles are there? How many X particle X? Two corners are present in the body diagonal. So 1/8 into 6 corners. Isn't it? Face particle missing ഉണ്ടോ? ഇല്ല. Face particle ഒന്നും മിസ്സായിട്ടില്ല. 6 faces ഉണ്ട്. Half of 6 അങ്ങനെ തന്നെയുണ്ട്. ഇനി Y particle എവിടെയൊക്കെ ഉണ്ടായിരുന്നേ? Octahedral voids. Octahedral എവിടെയാ? എഡ്ജ് സെന്ററും ബോഡി സെന്ററും. എഡ്ജ് സെന്റർ മിസ്സായിട്ടുണ്ടോ? ഇല്ല. പക്ഷെ ബോഡി സെന്ററോ? അത് മിസ്സായി. ബോഡി സെന്ററിൽ ഇല്ല. Z particle എവിടെയായിരിക്കുന്നത്? Z particle ഇരിക്കുന്നത് ടെട്രാഹീഡ്രൽ വോയിഡ്സിലാണ്. യു നോ ദാറ്റ് ടെട്രാഹീഡ്രൽ വോയിഡ് രണ്ടെണ്ണത്തിൽ കൂടെയാണ് ബോഡി ഡയഗണൽ പാസ് ചെയ്യുക. അപ്പോൾ ബാക്കി 6 ടെട്രാഹീഡ്രൽ വോയിഡിൽ Z ഇരിപ്പുണ്ട്. അത് ഷെയർ ചെയ്യാൻ പറ്റില്ല. സോ എക്സ് എത്രയാണ്? എക്സ് 3/4 പ്ലസ് 3. കറക്റ്റ് അല്ലേ? അപ്പോൾ എത്രയാണ് കിട്ടുക? 15/4. വൈയോ? Y3. Z 6. സോ വി ക്യാൻ സേ എക്സ് 15/4, Y3, Z 6. 3 കൊണ്ട് കട്ട് ചെയ്താലോ എന്താ കിട്ടുക? അവിടെ 2, ഇവിടെ 5. സോ യു ക്യാൻ സേ X5, Y4, Z8. അങ്ങനെയാണോ കിട്ടിയ? X5 ഉള്ള ഒരൊറ്റ ആൻസറേ ഉള്ളൂ. ക്ലിയർ? ക്വസ്റ്റ്യൻ നമ്പർ 83. വാട്ട് അബൌട്ട് ക്വസ്റ്റ്യൻ നമ്പർ 83? ഇൻ CCP lattice X and Y, X atoms present corners while അങ്ങനെയാണ്. CCPയിലാണ്, പക്ഷേ X and Y are in CCP. അല്ലാണ്ട് X alone CCPയിലല്ല. Suppose X is present at corners. You can say 1/8 into 8. Y present in face centers. That is half of 6. Isn't it? Then a corner is replaced by Z atoms. So actually X is present in 7 corners only. Isn't it? Whereas Z present 1 corner. So X is 7/8, Y is 3, Z is 1/8. Multiplying by 8 you will get X7, Y 24, Z 1. So X7, Y is 24. What will be the answer? Option B, right? Let me go to next one. Question number 84. Number of second nearest of metal atom which crystallizes in BCC is X. What is this X stands for? Number of second nearest. BCC ഒന്ന് നോക്കിയേ. What about BCC? BCC ഒന്ന് നോക്കാവോ? In BCC, you know, particles, one particle is here. ഇവിടെയൊക്കെ particles ഉണ്ട്. BCC പറഞ്ഞ corners and body center is occupied. What is the first nearest? ഇതിന്റെ first nearest is this, no doubt. This is the first nearest particle. There are 8 first nearest particle for BCC. What is the second nearest? To get the second nearest, you just take 6 more units a year. you can take 6 more unit cell. Each phase is extrapolated to get unit cell. ഓരോ ഫേസും നമ്മൾ ഓരോ യൂണിറ്റ് സെല്ലിലേക്ക് എക്സ്ട്രാപ്പൊളേറ്റ് ചെയ്യാം അല്ലേ. ഫ്രണ്ടിലോട്ടൊന്നുണ്ടാവും, പിറകോട്ടൊന്നുണ്ടാവും. ഓരോ യൂണിറ്റ് സെല്ലിനകത്ത് ഓരോ ബോഡി സെന്റേഡ് പാർട്ടിക്കിൾ ഉണ്ട്. അതാണ് നെക്സ്റ്റ് നിയറസ്റ്റ്. അപ്പൊ ഇവന്റെ ഫസ്റ്റ് നിയറസ്റ്റ് ഏതാണ്? ഇതാണ് ഫസ്റ്റ് നിയറസ്റ്റ്. നെക്സ്റ്റ് നിയറസ്റ്റ് ഇവിടെയുണ്ട്, ഇവിടെയുണ്ട്, ഇവിടെയുണ്ട്. സെയിം വേ one is in front of it, one is back side of it. So how much next nearest particles are there? 6, isn't it? 6 next nearest particle ഉണ്ട്. So I got x as 6. What about y? What about y? Y is the next number of second nearest metal atom in which crystallizes in FCC. You just take FCC arrangement. FCC arrangement എങ്ങനെയായിരിക്കും? Take the FCC arrangement. Particles are present in corners and in face centers, right? Suppose you are considering a face centered particle, or you can take particle in the corners. These are all corner particles. Clear? What is the first nearest to it? A corner particle having first nearest means face center particle, no doubt, isn't it? Corner particle first nearest is what? Face center particle ആയിരിക്കും. What is the next nearest? Next nearest is corner particle. Corner to corner is the second nearest, right? So ഇവന്റെ നിയറസ്റ്റ് ആരൊക്കെ ഉണ്ടാവും? Suppose this is second nearest, this is second nearest, and if you take here you can see a second nearest, here you can see a second nearest, and if you can take in this way. So how many second nearest particle? Y is also equal to 6. So what will be x minus y? X minus y equal to 0. I hope you are following, right? Let me go to the next one. Question number 85. Come on, try to do this. These are all most probable questions. കുറച്ച് പേര് ഇപ്പോഴും ഉണ്ടല്ലോ അല്ലേ? കേൾക്കുന്നുണ്ടോ എന്നെ? ശ്രദ്ധിക്കുന്നുണ്ടല്ലോ? കുറച്ച് പേര് മാത്രമേ ഫൈനൽ വരെ എത്തുന്നുള്ളൂ. ഓക്കെ അല്ലേ? What about this one? M1, M2. Oxidation of ion, CCP lattice structure. Cation M1 occupies 50% of octahedral voids and M2 occupies 12.5% void oxide ions. Oxidation number of M1 and M2 respectively. ഇതെങ്ങനെ കണ്ടുപിടിക്കും? കണ്ടുപിടിക്കാൻ പറ്റുന്നുണ്ടോ നിങ്ങൾക്ക്? എങ്ങനെയാണ്? M1, M2 oxide ions ഉണ്ട്. 3 ആളുണ്ട്. ക്രിസ്റ്റൽ ആരുണ്ട്? M1 is there, M2 particle is there, and also oxide particle is also there. അല്ല, ഇവരൊക്കെ ഉണ്ട്. Oxide ions form CCP. അപ്പോൾ you can take 1 mole oxide ion. എപ്പോഴും അങ്ങനെയല്ലേ നമ്മൾ എടുക്കുക. Suppose there are 1 mole oxide ion. 1 mole oxide ion is there. M1 occupy 50% of octahedral voids. How many octahedral voids will be there? 1 mole. So how many M1 particles are there? Half mole. Why? Half of the octahedral void is occupied by M1. So the M1 particle is half mole, right? Then what about M2 particle? M2 occupied 12.5% of tetrahedral void. How many tetrahedral voids are there? 2 mole tetrahedral voids, because 1 mole oxide ions are arranged. So the number of tetrahedral void will be double. So 2 mole tetrahedral void will be there. For 12.5% means what? 1 by 8 fraction, right? 1 by 8 fraction is there. So M1 is, suppose M1 is half mole, M2 is 1 by 4 mole, O2 minus is 1 mole. Multiplying by 4, you can write M1, 2, M2 is 1. Am I right? Oxide ion is 4. Do you agree with me? മനസ്സിലായോ എല്ലാവർക്കും? എങ്ങനെയാണ്? ഓക്സൈഡ് അയോൺ 1 മോൾ. M1 എത്രയാണ്? M1 is 50% of octahedral void. എന്ന് വെച്ചാൽ ഹാഫ് ഓഫ് ദ octahedral voidൽ M1 ഉണ്ട്. M2 എത്രയാണ്? 1 by 8 of tetrahedral void. Tetrahedral void is double. It's 1 by 8. Oxide ion 1 mole. So you can write it M1 half, M2 1 by 4, oxide ion is 1. Multiply the 4 on that. So you can write M1 2, M2 1, oxide ion 4. Crystal should be electrically neutral. So what should be the possible charge? ഇത് രണ്ടിൻ്റെയും ചാർജ് ആഡ് ചെയ്താൽ M1 രണ്ടെണ്ണത്തിൻ്റെയും M2 1ൻ്റെയും ചാർജ് ആഡ് ചെയ്താൽ you need to get +8. So here it is -2 4s are ആരാണ് -8. So ഇത് ആഡ് ചെയ്ത് കഴിഞ്ഞാൽ you will get what? +8. So +8 കിട്ടണം. ഇതിൽ ഏത് കോമ്പിനേഷൻ എടുക്കാൻ പറ്റും? Can you take this combination? Let us see. 2 into +2 plus 1 into +4. Correct. You will get +8. So the correct option is option A. Clear? Let me go to the next one. What about question number 86? In FCC lattice A, B, C, D atoms are arranged at corner, face center, octahedral void, tetrahedral void. Then the body diagonal contain. Please do it yourself. Body diagonal particles. If you draw a body diagonal in this way, ആരൊക്കെ വരും അതിനകത്ത്? Where is this A present? Corners. അപ്പോൾ A കോർണേഴ്സിലുണ്ട്. ഇപ്പോൾ 2 കോർണർ പാർട്ടിക്കിൾ A വരും. അപ്പോൾ A 2 പാർട്ടിക്കിൾ വരും. B present where? B ഫേസ് സെന്റേഴ്സിലാണ്. B പാർട്ടിക്കിൾ ഒന്നും വരില്ല. ബോഡി ഡയഗണൽ വിൽ നോട്ട് ടച്ച് ദ ഫേസ് സെന്റേർഡ് പാർട്ടിക്കിൾ. B is 0. What about octahedral voids? Octahedral void is edge center and body center. This is octahedral site. അവിടെ ആരുണ്ട്? Octahedral void is occupied by C. So there is one C particle. Where is this D stands for? Tetrahedral void. Tetrahedral void, you know, there are 2 tetrahedral void. So 2D. So the correct option is option A. Clear? Let me go to the next one. 87. A2- form cubic close packed arrangement. Cation B2 plus occupy 25% of octahedral void, while B3 plus occupy equal number of tetrahedral and octahedral holes. Number of octahedral holes occupied by B2 plus and B3 plus are equal. Then formula of the molecule is. Can you do it? Anions A2- form CCP arrangement. ഇതൊക്കെ കുറച്ച് ട്രിക്കി ക്വസ്റ്റ്യൻസ് ആണ്. Try to do yourself. ഒന്ന് വായിച്ച് സ്വന്തമായിട്ട് ചെയ്യൂ. A2- ions CCP. A2 negative ions, let me take it as 1 mole. You are taking 1 mole A2- since it is CCP arrangement. B2 plus എവിടെയാണ്? 25% of octahedral holes. If 1 mole particles are arranged, how many octahedral voids will be there? 1 mole. So out of this 1 mole, B2 plus is 25%. Clear? Then B3 plus is also there. Where is this B3 plus present? Occupy equal number of tetrahedral holes and octahedral voids. And again they say number of octahedral holes occupied by B2 plus and B3 plus are equal. You know, B2 plus is, how many B2 plus is already we have seen? 1/4 mole B2 plus is there. So 1/4 mole B3 plus occupies in octahedral voids. 1/4 mole B3 plus occupy in tetrahedral voids also. Clear? So B2 plus എത്രയാണുള്ളത്? 1/4. B3 plus എങ്ങനെയാണെന്നാ പറഞ്ഞത്? B2 plus എത്ര octahedral ഹോൾസിൽ ഇരിക്കുന്നുണ്ടോ അത്ര തന്നെ B3 പ്ലസും octahedral ഹോൾസിൽ ഉണ്ട്. That means B3 plus is 1/4 in octahedral holes and 1/4 in tetrahedral holes. So 2/4 B3 plus is there. A2- present is 1 mole. Multiplying by 4, you can write B2 plus 1, B3 plus 2, A2- 1. Clear? You can write B3, how much? Multiplying by 4, you can write B3A4. Am I right? You will get B3A4 as the answer. എന്താണ് സംശയം വന്നോ? കൺഫ്യൂസ് ആവുന്നോ? അശ്വതി, am I want to repeat the same question? ഞാൻ ഈ ക്വസ്റ്റ്യൻ ഒന്നുകൂടി റിപ്പീറ്റ് ചെയ്യാം. What the question says, read it. A2- CCP. A2- present in CCP. You can take it as 1 mole. Okay. Then B2 plus, where is B2 plus occupies? 25% of octahedral voids. If 1 mole A2 minus ions are arranged, how many octahedral voids will be there in the crystal? 1 mole. Isn't it? Its 25% is B2 plus. So B2 plus is 25 by 100, that is 1 by 4 mole. Do you agree with me? They say B3 plus equal number, B3 plus octahedral void ഉണ്ട് tetrahedral void ഉണ്ട്. Octahedral void എത്ര ഇരിക്കുന്നുണ്ടോ അത്ര തന്നെ tetrahedral void ഉണ്ട്. Octahedral void എത്ര ഇരിക്കുന്നുണ്ട്? എത്ര B2 plus octahedral void ഇരിക്കുന്നുണ്ടോ അത്ര തന്നെ B3 plus octahedral void ഉണ്ട്. അപ്പോൾ B3 plus octahedral void എത്രയുണ്ട്? That is 1 by 4 mole. അപ്പോൾ B3 plus tetrahedral voids എത്ര ഇരിപ്പുണ്ട്? That is 1 by 4 mole. So you can say B2 plus 1 by 4 mole ഉണ്ട്. B3 plus 1 by 4 plus 1 by 4 half mole ഉണ്ട്. O2 minus അല്ല A2 minus 1 mole ഉണ്ട്. പിടികിട്ടിയോ? So we can say total B is 3 by 4. A is 1. B3 A4. So the formula is A. I hope it is clear now. Ashwadiയുടെ confusion മാറിയോ? Let me go to the next one. Question number 88. ഇപ്പം വളരെ നീഡി ആയിട്ടുള്ള കാൻഡിഡേറ്റ്സേ ഉള്ളൂ അല്ലേ? Diameter of largest sphere that fits the void of corner of a cube edge of BCC. ഇത് റിപ്പീറ്റിംഗ് ക്വസ്റ്റ്യൻ ആണ്. BCCയുടെ നമ്മൾ പറഞ്ഞതാണിത്. BCCയുടെ എഡ്ജിന്റെ സെൻട്രൽ ഒക്യുപ്പൈ ചെയ്യാൻ പറ്റിയ സ്ഫിയറിന്റെ ലാർജസ്റ്റ് ഡയമീറ്റർ ആണ് ഇവിടെ ചോദിച്ചത്. തൊട്ട് മുമ്പത്തേല് റേഡിയസ് ആയിരുന്നു എന്ന് മാത്രം. റേഡിയസ് കാൽക്കുലേറ്റ് ചെയ്ത് ഓർക്കുന്നുണ്ടോ? സോ ഇപ്പോൾ ഡയമീറ്റർ എടുത്താൽ എന്തായിരിക്കും കിട്ടുക? ഐ തിങ്ക് ദ ആൻസർ എക്സ്പെക്റ്റഡ് ഈസ് സി. ആം ഐ റൈറ്റ്? എങ്ങനെയാ ചെയ്തതെന്ന് ഓർമ്മയുണ്ടോ? ഹൗ ഡു യു ഗോട്ട് ഇറ്റ്? ഐ ടോൾഡ് യു A minus 2R. A minus 2R is required. A minus 2R is required, right? How do you got A minus 2R? These are the radius of the spheres that form BCC. BCC ഉണ്ടാക്കുന്ന സ്ഫിയർ ആണ് ഞാൻ കോർണറിൽ വെച്ചിരിക്കുന്നത്. ഇനി ഞാൻ ചെയ്യേണ്ട കാര്യമില്ല അല്ലേ? You got that answer as C. This is a repeating question. What about question number 89? Please do it. Question number 89. Number of unit cell in 4 gram of X. Atomic mass 40. How many moles X is there? Number of moles of X is equal to given mass by molar mass. You are given with 0.1 mole X. What is the rank of BCC? 2. എന്ന് വെച്ചാൽ in order to create one unit cell you require 2X particle. But 2X particle if present you can get one unit cell. So the number of unit cell is half of the number of spheres present. You are given with a 0.1 mole particle. So how much unit cell can be created? 0.1 divided by 2 mole unit cell can be created. Clear? 0.1 by 2 into Avogadro number. Let me go to question number 90. This is an NCERT textbook question, all of you know. 0.5 mole compound is present. How many voids are there? You know the number of tetrahedral void will be double the number of spheres. Number of sphere is 0.5 mole. So tetrahedral void is 1 mole. How many octahedral void will be there? Equal to the number of spheres. So how many total voids are there? 1.5 moles. So in order to get total number of voids, you can multiply the number of sphere into 3. So 1.5 mole, 1.5 into Avogadro number. Clear? Question number 91. Paramagnetic substances have. I told you this is a repeating question. In magnetic domains are aligned in opposite direction in unequal numbers so that they have very small net magnetic moment. Question number 92. Substances which is weakly repelled. You know water, benzene, sodium chloride. These are all diamagnetic. If you take water in YouTube and if you show a magnetic pole in one of the limb, what will happen? Water in that limb is lowered. Isn't it? That suggests what? Water is diamagnetic. It will be repelled in the magnetic field. How will you find out the packing efficiency in this diagram? It is a two-dimensional packing. If you take a square, what is the area of the square? A square. What is the space? What is the area occupied? You will not take space. Area occupied. There are two circles occupied. 2 pi r square occupied. Right? You know what is a root 2? A root 2 equal to 4r. So you can replace either r or a here. So 2 into 3.14 into, you can say a root 2 equal to 4r. So what will be r? You can say r is equal to a root 2 by 4, or you can convert a into r, isn't it? So r square you can keep it as such. What is a? A is 2 root 2 r. Take the square of it. So 2 into 3.14 into r square divided by 2 square is 4. Root 2 square is 2 into r square. So you can say what? 3.14 by 4. 3.14 divided by 4. You will get what? Approximately 78. Am I right? 7 3s are 7 4s are 28. Am I right? Let me go to question number 94. Come on, do it. Question number 94. In face-centered crystal lattice, edge length is 400 picometer. A is given as 400 picometer. Diameter of the greatest sphere, which can be fitted into interstitial void without distortion of lattice. In FCC, there are two types of voids. What are they? Tetrahedral void and octahedral void. Which is bigger void? Octahedral void. Alle, pidikittiyo chodyam. The question asked is, you are arranging the particle in FCC. So there will be two types of void in it. Radius of the octahedral void is bigger than tetrahedral void. Now, the biggest sphere void we are placing in the octahedral void. Isn't it? So we know that radius of the void divided by radius of the sphere for an octahedral void is 0.414. Clear? The problem here is radius of the sphere is not given. Instead, edge length is given. We know that for an FCC, a root 2 equal to 4r, where r is the radius of the sphere. Clear? So, radius of the void is equal to 0.414 into radius of the sphere. That is 0.414 into radius of the sphere. What is the radius of the sphere? A root 2 by 4. A root 2 by 4. That is 0.414 into, what is A here? 400 picometer into root 2 divided by 4. So you can do it and finalize the answer. Okay, let me go to question number 95. Question number 95. This is not strictly now in your syllabus. This is based on Bragt's equation. What is this Bragt's equation? 2d sin theta equal to n lambda. 2d sin theta equal to n lambda. You know the result. 2 into d is distance between the plane that you want to find out. Sin 60 can be taken as root 3 by 2. N is called the order of diffraction. Here the order of diffraction is second order. What is the wavelength? 1 angstrom. So you can find out d. What will be d? T equal to 2 by root 3. That is 2 by 1.732. Can you guess the answer? Only possible answer is option D, right? Question number 96. Can you do question number 96 here? How will you do question number 96? AB crystallizes in rock salt structure. A is to B is 1 is to 1. That we know in rock salt structure. NaCl, A and B 1 is to 1 ratio. Shortest distance between A and B. I told you, rock salt structure in the ketadum namala manasil varandad endana. Rock salt structure in the ketadum, you should know that anions are in the corners and cation in the edge center. Rock salt structure in the ketadum, you should know anions are in the corner and cation in the edge center. So the shortest distance between AB, this distance, that is given as y raised to 1 by 3 nanometer. So what will be the edge length? Edge length will be double of it. So A equal to, what is A? A equal to 2 times y raised to 1 by 3 nanometer. Clear? Rock salt structure എന്ന് കേട്ടത് നമ്മൾ ഓർക്കണം. Anions corner edge center is situated by the cation. So from cation to anion distance is half of the edge length. Clear? So to get the edge length, take the double of the closest distance between cation and anion. So this is the edge length. Clear? What do you want to find out? Theoretical density. What is density? Zm by a cube into Avogadro number. What is Z here? Don't forget, for rock salt structure, Z is 4. How do you got it? We know in rock salt structure, chloride ions are in FCC. Chloride ions are present in 8 corners and also in the face centers. So there will be 4 chloride ions. Sodium ions are in edge center and in body center. Contribution of edge center is 1 by 4. There are 12 edges plus 1 in the body center. So total of 4. 4 sodium ion and 4 chloride ion present in 1 unit cell of NaCl. So number of NaCl unit per unit cell is 4. So D equal to Zm by A cube into Avogadro number. Z is 4. M is 6.023 YAMU unit. That means 6.023 Y gram for 1 mole. But the answer is in kilogram. So this into 10 to the power of minus 3 kilogram for 1 mole. So I am dividing here by molar mass. Number of moles also. 6.02 into 10 to the power of 23 A cube. What is edge length? A is, we know A is 2 into y raised to 1 by 3 nanometer. 2 into y raised to 1 by 3 whole cube. You are following? So you can say 4 into 6.023 into y into 10 to the power of minus 3 divided by 2 cube is 8. Y cube is, cubic root of y is taken with the cube. So it become y. ശരിയല്ലേ? This is cubic root of y. Cube എടുത്തു. yi into 6.023 into 10 to the power of 23. Isn't it? But the unit given here is which unit? Y into 2y raised to 1 by 3. Which unit? In nanometer. I want to write it in meter. So please convert it into meter. 10 to the power of how much? Minus 9. Am I right? 10 to the power of minus 9 should be there. So take the root. I will repeat this procedure again. Okay, let me repeat this. Ready or not? What about here? They say AB is in rock salt type. AB is in rock salt type means you know Z is 4. What about edge length A? Edge length A is twice y raised to 1 by 3 nanometer. Clear? So D equal to Zm 4 into, what is the molar mass of here? Molar mass of the here is 6.023 into y into 10 raised to minus 3 kilogram divided by A cube. What is A here? 2y raised to 1 by 3 into 10 raised to minus 9 meter. Isn't it? Take the cube of it. This is A cube into Avogadro number 6 into 10 to the power of 23. Clear? Now can you do it? 4 into, you can cancel this 6.023 here. So 4 into y can also be cancelled. 4y into 10 to the power of minus 3 divided by 2 cube is 8. This is y. This is 10 to the power of minus 27 here. 10 to the power of 23. So this become 10 to the power of minus 4. Here it become 10. Y can be cancelled. 40 by 8. That will give 5 kilogram per meter cube. Clear now? Can you do this question? Now Only 3 more questions remains. Do you want to do it as a homework or am I want to do it? ചെയ്യണോ ഞാൻ? Question number 97 പറയട്ടെ? ശ്രദ്ധിച്ചിരിക്കുന്നുണ്ടോ? കുറച്ച് പേരുണ്ട്, മോസ്റ്റ് നീഡി ആയിട്ടുള്ള ആൾക്കാരൊക്കെ ഉണ്ട്. ഓക്കെ, ഈ ക്വസ്റ്റ്യൻ നോക്കൂ. NaCl സ്ട്രക്ചർ അഗെയിൻ. NaCl സ്ട്രക്ചറിൽ എങ്ങനെയാണ്? They say Al3 plus ion replace Na plus ions at the edge centers of NaCl. NaClന്റെ എഡ്ജ് സെന്ററിലുള്ള ആരെയാ നമ്മൾ റീപ്ലേസ് ചെയ്തത്? Na പ്ലസ് അയോൺ അറ്റ് എഡ്ജ് സെന്ററിലുള്ളതൊക്കെ റീപ്ലേസ് ചെയ്ത് Al3+ വെച്ചു കൊടുത്തു. അങ്ങനെയല്ലേ പറയുന്നത്? അപ്പോൾ 1 മോൾ NaCl ഉണ്ട്. ദാറ്റ് മീൻസ് 1 മോൾ Na+ ഉണ്ട്, 1 മോൾ Cl- ഉണ്ടായിരുന്നു. അതിൽ നമുക്കറിയാം സോഡിയം അയോൺസ് ആർ പ്രസന്റ് ഇൻ എഡ്ജ് സെന്റർ ആൻഡ് ഇൻ ദ ബോഡി സെന്റർ. എഡ്ജ് സെന്ററിന്റെ കോൺട്രിബ്യൂഷൻ എത്രയാ? 1/4 × 12. അപ്പോൾ ബോഡി സെന്റർ 1. സപ്പോസ് ദർ ആർ 4 സോഡിയം അയോൺസ്. ഈ 4 സോഡിയം അയോൺസ് ഉണ്ടെങ്കിൽ 3 sodium ions obtained from edge centers. 3 sodium ions from edge center, 1 sodium ion from body center. You have total എത്ര sodium ions ഉണ്ട്? 1 mole. So edge central എത്ര sodium ions ഉണ്ട്? edge central ഉണ്ടായ sodium ion എത്ര കാണും? ആകെ നിങ്ങളുടെ കയ്യിൽ 1 mole sodium ion ഉണ്ട്. അതിൻ്റെ 3/4 mole sodium ion എവിടെയാണ്? edge central ആണ്. 3/4 മോൾ സോഡിയം അയോൺ ഇരിക്കുന്നത് എഡ്ജ് സെൻറ്ററിലാണ്. 1/4 മോൾ സോഡിയം അയോൺ ഇരിക്കുന്നത് എവിടെയാണ്? ബോഡി സെൻറ്ററിലാണ്. 3/4 മോൾ സോഡിയം അയോൺ റീപ്ലേസ് ചെയ്ത് നിങ്ങൾ Al3+ വെച്ചു. 3 സോഡിയത്തിനെ മാറ്റിയ ഒരു Al3+ വെച്ചാൽ മതി, എന്നാലേ ഇലക്ട്രിക് ന്യൂട്രാലിറ്റി കിട്ടുള്ളൂ. അപ്പം നിങ്ങൾ വെച്ചിരിക്കുന്ന Al3+ എത്രയാണ്? നിങ്ങൾ വെച്ചിരിക്കുന്ന Al3+ 1/4 മോൾ Al3+ ആണ് വെച്ചത്. നിങ്ങൾ റിമൂവ് ചെയ്ത Na+ അയോൺ എത്രയാണ്? 3/4 മോൾ Na+ റിമൂവ് ചെയ്തു. എന്നിട്ട് പകരം നിങ്ങൾ അവിടെ ഒരു 1/4 മോൾ Al3+ വെച്ചു. അപ്പോൾ വോയിഡ് എത്ര ബാക്കിയുണ്ട്? 1/2 മോൾ വോയിഡ് ബാക്കിയാണ്. 1/2 മോൾ വോയിഡ് ഉണ്ട്. 1/2 × അവഗാഡ്രോ നമ്പർ വോയിഡ് എന്ത് വന്നു? വോയിഡ് ഉണ്ടായി. 1/2 × അവഗാഡ്രോ നമ്പർ വേക്കൻറ്റ് സ്പേസസ് വന്നു. ക്ലിയർ നൗ? അടുത്തതിലേക്ക് പോവാം. 98 ഇത് ഇല്ല, സിലബസിൽ ഇല്ല. മില്ലർ ഇൻഡിസസ് ആണ്. അഥവാ ചോദിക്കുവാണെങ്കിൽ നിങ്ങളൊന്ന് ഓർത്തു വെച്ചോളൂ. പ്രൊസീജിയർ ഞാൻ പറയാം. അവർ പറയാണ് ഒരു ക്രിസ്റ്റൽ പ്ലെയിൻ പാസ് ചെയ്യുന്നത് എങ്ങനെയാണെന്നാണ് പറയണേ? ഒരു സ്ഥലത്ത് ഇന്റർസെക്ട് ചെയ്യുന്നത് 0.5-ലാണ്. 0.5-ലാണ്. മറ്റേ സ്ഥലത്ത് ഇന്റർസെക്ട് ചെയ്യുന്നത് 1.5-ലാണ്. വേറൊരു സ്ഥലത്ത് ഇന്റർസെക്ട് ചെയ്യുന്നത് 0.75 യൂണിറ്റിലാണ്. ഇങ്ങനെ വന്നാൽ നിങ്ങൾ ആദ്യം തന്നെ ടേക്ക് ദ കോയിഫിഷ്യന്റ് ഓഫ് ഇറ്റ്. കോയിഫിഷ്യന്റ് എടുക്കുക. ഇതാണ് അതിൻ്റെ കോയിഫിഷ്യന്റ്. വേണമെങ്കിൽ എനിക്ക് ഐ ക്യാൻ റൈറ്റ് ഇറ്റ് ഇൻ ദിസ് വേ ഓൾസോ. ഇതാണ് കോയിഫിഷ്യന്റ്. ടേക്ക് ദ റെസിപ്രോക്കൽ ഓഫ് ഇറ്റ്. 2, 2/3, 4/3. മൾട്ടിപ്ലൈ വിത്ത് LCM. 3 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്താൽ 6, 2, 4. സോ ദ മില്ലർ ഇൻഡസസ് ഈസ് 624. സിമ്പിൾ. ടേക്ക് ദ കോയിഫിഷ്യന്റ്, ടേക്ക് ദ റെസിപ്രോക്കൽ, മൾട്ടിപ്ലൈ വിത്ത് LCM. ഓക്കെ, ഐ ഹോപ്പ് യു ഗോട്ട് ഇറ്റ്. ക്വസ്റ്റ്യൻ നമ്പർ 99. ഇത് സിമ്പിൾ ആണ് അല്ലേ? റോക്ക് സാൾട്ട് ടൈപ്പ്. റോക്ക് സാൾട്ട് ടൈപ്പ് എന്ന് പറഞ്ഞാൽ എന്താ? Mg2+ അയോൺ വിൽ ബി ഇൻ കോണ്ടാക്ട് വിത്ത്. ഞാൻ പറഞ്ഞു റോക്ക് സാൾട്ട് ടൈപ്പ് 6-6 കോർഡിനേഷൻ ആണ്. 1 Na+ സറൗണ്ടഡ് ബൈ 6 ക്ലോറൈഡ് അയോൺ, ഈച്ച് ക്ലോറൈഡ് അയോൺ സറൗണ്ടഡ് ബൈ 6 സോഡിയം അയോൺ. 6-6 കോർഡിനേഷൻ ആണ് റോക്ക് സാൾട്ട് ടൈപ്പ്. ക്വസ്റ്റ്യൻ നമ്പർ 100ലേക്ക് പോവാം. എന്താ തന്നിരിക്കുന്നത്? Fe7S8 ആണ്. എനിക്ക് തോന്നുന്നു ഇതൊക്കെ പ്രിൻസിപ്പിൾ ഓഫ് ന്യൂട്രാലിറ്റി എടുത്ത് ചെയ്താൽ മതി നിങ്ങൾക്ക്. Fe2+ ഉണ്ട്, Fe3+ ഉണ്ട്, S2- ഉണ്ട്. 2+ എത്രയുണ്ട് എന്ന് വിചാരിക്കാം? X ഉണ്ട് വിചാരിച്ചോളൂ. 3+ഓ? 3+ അന്നേരം 7 - X, കാരണം ടോട്ടൽ 7 ആണ്. സൾഫൈഡ് അയോൺ 8 ഉണ്ട്. ന്യൂട്രാലിറ്റി എടുക്കൂ. 2x + 3 × 7 - X ഈക്വൽ ടു -2 × 8 എന്ന് പറഞ്ഞാൽ -16. അപ്പോൾ ഇതെല്ലാം കൂടി ആഡ് ചെയ്താൽ +16 കിട്ടണം. എന്നാലല്ലേ ന്യൂട്രൽ ആവുള്ളൂ. ഇനി ഞാൻ ചെയ്യേണ്ട കാര്യമില്ല അല്ലേ? 2x - 3x എന്ന് പറയുമ്പോൾ -x, 16 - 21 എന്ന് പറയുമ്പോൾ -5. സോ x ഈസ് ഈക്വൽ ടു 5. അപ്പോൾ 2+ ഇരിക്കുന്നത് 5. അപ്പോൾ 5:2 അല്ലേ കിട്ടിയത്? ഓക്കെ, കൺക്ലൂഡ് ചെയ്യാം. ഇത്രയും പേര് ആയിട്ട് ഒരുപാട് സമയമെടുത്തു. എനിവേ കുറേ പേര് കോപ്പറേറ്റ് ചെയ്തിരുന്നു. താങ്ക് യു. എന്തായാലും കുറച്ച് ടഫായിരുന്നു, ഹാർഡർ ആയിട്ടുള്ള ക്വസ്റ്റ്യൻസ് ആയിരുന്നു. മലയാളത്തിൽ ഈ ക്വസ്റ്റ്യൻസ് ഒന്നായിട്ട് എക്സ്പ്ലെയിൻ ചെയ്യണമെന്ന് ആഗ്രഹമുള്ളവരുണ്ടെങ്കിൽ ഞാനത് ഒന്നുകൂടി പറയാം, ഒന്നും പേടിക്കേണ്ട കാര്യമില്ല. പക്ഷെ ഞാനൊരു എക്സ്പെരിമെൻ്റ് എന്ന നിലയ്ക്ക് ഞാൻ വേഗം ക്വസ്റ്റ്യൻ നിങ്ങൾ പെട്ടെന്ന് കൺസെപ്റ്റ് മനസ്സിലാക്കാൻ വേണ്ടി ഞാൻ വേഗം പോയിന്നേ ഉള്ളൂ. നന്ദന 97th ക്വസ്റ്റ്യൻ ഒന്നുകൂടി ചോദിക്കുന്നുണ്ട്, ഞാൻ അതുകൂടി ഒന്ന് പറയാം. 97th ക്വസ്റ്റ്യൻ നന്ദനെ ഒന്നുകൂടി റിപ്പീറ്റ് ചെയ്യാൻ പറയുന്നുണ്ട്. നന്ദനെ ക്വസ്റ്റ്യൻ ഇങ്ങനെയാണ്. നന്ദനയ്ക്കറിയാം 1 മോൾ NaCl എടുത്താൽ, NaClന്റെ സ്ട്രക്ചർ നന്ദനെ ഒന്നുകൂടി മനസ്സിൽ കൊണ്ടുവരും. NaCl സ്ട്രക്ചർ എന്ന് പറഞ്ഞാൽ സോഡിയം അയോൺസ് ആർ ഇൻ ഒക്ടാഹീഡ്രൽ വോയിഡ്സ്, ക്ലോറൈഡ് അയോൺസ് ആർ ഇൻ FCC എന്നാണ്. ഒക്ടാഹീഡ്രൽ വോയിഡ്സിന്റെ ലൊക്കേഷൻ നന്ദനെ ഓർക്കൂ, എഡ്ജിന്റെ സെൻട്രലും ബോഡി സെൻട്രലും ആണ് ഇരിക്കുന്നത്. എഡ്ജിന്റെ സെൻട്രലും അതുപോലെ തന്നെ ബോഡി സെൻട്രലും ആയിട്ടാണ് ആയിരിക്കുന്നത്, സോഡിയം അയോൺസ് ഇരിക്കുന്നത്. ഓക്കെ, ഇപ്പൊ എഡ്ജിന്റെ സെൻട്രൽ ഇരിക്കുന്നത് ഇനി നോക്കൂ നന്ദനെ, എഡ്ജിന്റെ കോൺട്രിബ്യൂഷൻ 1/4 അല്ലേ? അങ്ങനെ 12 എഡ്ജസിൽ സോഡിയം അയോൺ ഉണ്ട്. പിന്നെ 1 ബോഡി സെൻട്രലുണ്ട് അല്ലേ? 1 ബോഡി സെൻട്രലുണ്ട്. അങ്ങനെ ഒരു യൂണിറ്റ് സെല്ലിനകത്ത് 4 സോഡിയം അയോൺ ശരിക്കുണ്ട് അല്ലെ? ഇപ്പൊ 4 മോൾ സോഡിയം അയോണ് നന്ദനന്റെ കയ്യിൽ തന്ന 3 മോൾ സോഡിയം അയോൺ വരുന്നത് എഡ്ജ് സെന്ററിൽ നിന്നാണ്. 3 മോൾ സോഡിയം അയോൺ വരുന്നത് എവിടെ നിന്നാണ്? എഡ്ജ് സെന്ററിൽ നിന്നാണ്. 1 മോൾ സോഡിയം അയോൺ വരുന്നത് ബോഡി സെന്ററിൽ നിന്നാണ്. അങ്ങനെയാണെങ്കിൽ 1 മോൾ സോഡിയം അയോണാണ് ഞാൻ നിന്റെ കയ്യിൽ തന്നത് വിചാരിക്കാം. അങ്ങനെയാണെങ്കിൽ 1 മോളിന്റെ 3/4 ഭാഗം, 3/4 മോൾ സോഡിയം അയോൺ എഡ്ജ് സെന്ററിൽ നിന്നാണ് വരുന്നത്. പിടികിട്ടിയോ? ഈ പറയുന്ന സോഡിയം ഒക്കെ നീ റിമൂവ് ചെയ്തു, അതൊക്കെ റിമൂവ് ചെയ്തു. എന്നിട്ട് അതിന് പകരം Al3+ വെക്കുക. നന്ദനയ്ക്കറിയാം 3 സോഡിയം അയോണിന് പകരം ഒരു Al3+ വെച്ചാൽ മതി. 3 സോഡിയം അയോണിന് പകരം ഒരു Al3+ വെച്ചാൽ മതി. ഇപ്പൊ 3/4 മോൾ Na+ എടുത്തു മാറ്റുവാണെങ്കിൽ നന്ദന എത്രയായിരിക്കും വെച്ചിട്ടുണ്ടാവുക? നന്ദന എത്ര വെച്ച് കാണും? 1/4 മോൾ Al3+ വെച്ച് കാണും. 1/4 മോൾ Al3+ അതിൽ വെച്ച് കാണും. ശരിയല്ലേ ഞാൻ പറഞ്ഞത്? നന്ദന എടുത്തു മാറ്റിയത് എത്രയാ? 3/4 മോൾ ആരെ എടുത്തു മാറ്റി? Na+ എടുത്തു മാറ്റി അല്ലെ? എന്നിട്ട് അതിന് പകരം എന്ത് ചെയ്തു? 1/4 മോൾ Al3+ അവിടെ നിറച്ചു വെച്ചു. അപ്പോൾ 1/2 മോൾ വേക്കൻ്റ് ആണ്, 1/2 മോൾ വേക്കൻസി വന്നു. അതാണ് ചോദ്യം. 1/2 മോൾ വേക്കൻസി എന്ന് പറഞ്ഞാൽ എത്രയാ? 3.01 × 10⁻23 ആണ്. നന്ദനയ്ക്ക് മനസ്സിലായോ? ഇനി ഏതെങ്കിലും ക്വസ്റ്റ്യൻ ഹാർഡറായി തോന്നിയോ? നിങ്ങൾക്ക് കൺസെപ്റ്റ് കിട്ടാത്തതുണ്ടായോ? ഉണ്ടെങ്കിൽ ചോദിച്ചാൽ ഞാൻ പറഞ്ഞുതരാം. ഒത്തിരി നേരമായി അല്ലേ? കുറേ നേരം എടുത്തു, ബോറടിച്ച് കാണും പലർക്കും. പക്ഷേ നീഡി ആയിട്ടുള്ള കാൻഡിഡേറ്റ്സ് അവിടെ വെയിറ്റ് ചെയ്യുന്നുണ്ടായിരുന്നു. അതുകൊണ്ടാണ് ഞാനത് കംപ്ലീറ്റ് ചെയ്തത്. തീർച്ചയായിട്ടും സെലക്ട് ചെയ്ത ക്വസ്റ്റ്യൻസ് കുറച്ച് ഹാർഡറാണ്. ഇനിയുള്ള റിമൈനിങ് യൂണിറ്റിൽ ക്വസ്റ്റ്യൻസ് കുറച്ച് ഹാർഡറായിട്ടാണ് നമ്മൾ സെലക്ട് ചെയ്യുക. എങ്കിലും അതായത് ഞാൻ ആദ്യമേ പറഞ്ഞു, നമ്മളെ പർപ്പസ് ജസ്റ്റ് ഏതെങ്കിലും ഒരു മെഡിക്കൽ കോളേജിൽ കയറാൻ വേണ്ടിയിട്ടല്ല, നല്ലൊരു മെഡിക്കൽ കോളേജിൽ നല്ല സീറ്റ് മേടിക്കാൻ വേണ്ടിയിട്ടാണ്. അതുകൊണ്ട് ഹാർഡറായിട്ടുള്ള ക്വസ്റ്റ്യൻസ് ഒക്കെ ചെയ്യണം. ക്വസ്റ്റ്യൻ നമ്പർ 84 അക്ഷയ്ക്ക് ഒരു ഡൗട്ട് പറയണം. ക്വസ്റ്റ്യൻ നമ്പർ 84 അത് സിമ്പിൾ ആണ്. ഇതെന്താ ചോദിച്ചിരിക്കണേന്ന് നോക്കിയേ. നിയറസ്റ്റ് നൈബർ, BCCയുടെ നിയറസ്റ്റ് നൈബറും നെക്സ്റ്റ് നിയറസ്റ്റ് നൈബറും എങ്ങനെയാ കണ്ടുപിടിക്കുക? അക്ഷയ, BCC എന്ന് വെച്ചാൽ എങ്ങനെയാ? BCC എന്ന് പറഞ്ഞാൽ പാർട്ടിക്കിൾസ് എവിടെയൊക്കെയാ ഇരിക്കണേ? കോർണറിലും ബോഡി സെന്ററിലും അല്ലേ? ഇപ്പൊ കോർണറിൽ ഇരിക്കുന്ന ഒരാളുടെ ഇതവിടെ ഒരു കോർണർ പാർട്ടിക്കിൾ ഉണ്ട്. അതിന്റെ നിയറസ്റ്റ് നൈബർ ഏതാ അക്ഷയന്റെ അഭിപ്രായത്തില്? നിയറസ്റ്റ് നൈബർ എന്ന് പറയുന്നത് ബോഡി സെന്ററിലുള്ള നിയറസ്റ്റ് നൈബർ കോർണറിലുള്ള ആളാണ്. അത് ഫസ്റ്റ് നിയറസ്റ്റ് ആണ്. പക്ഷെ എക്സ് എന്ന് പറയുന്നത് അതല്ല കേട്ടോ, നെക്സ്റ്റ് നിയറസ്റ്റ് ആണ്. അതിന്റെ അടുത്ത നിയറസ്റ്റ് എവിടെയാ അക്ഷയ കാണാം? ബോഡി സെന്ററിന് കോർണറിലുള്ളതാണ് ആദ്യത്തെ നിയറസ്റ്റ്. നെക്സ്റ്റ് നിയറസ്റ്റ് ഏതായിരിക്കും? നെക്സ്റ്റ് നിയറസ്റ്റ് എന്ന് പറയുന്നത് വീണ്ടും ഒരു യൂണിറ്റ് സെൽ എടുത്തു, ഇവിടെ ഇങ്ങനെ വീണ്ടും ഒരു യൂണിറ്റ് സെൽ എടുത്തു, പിന്നെ അതേപോലെ തന്നെ ഇവിടെ ഒരു യൂണിറ്റ് സെൽ എടുത്തു, അങ്ങനെ എല്ലാം എടുത്തു. അപ്പം അങ്ങനെയാണെങ്കിൽ ഈ പറയുന്ന ആളുടെ തൊട്ടടുത്ത് ഇവിടെ ഒരു നടുക്കൊരാളുണ്ടാവില്ലേ? അങ്ങനെ ഓരോ ഫേസും എക്സ്ട്രാപോളേറ്റ് ചെയ്ത് ഒരു യൂണിറ്റ് സെല്ലാക്കിക്കൂടെ നമുക്ക്? അങ്ങനെ യൂണിറ്റ് സെൽ ആക്കുവാണെങ്കിൽ ഓരോ ഫേസും നമ്മൾ എക്സ്ട്രാപോളേറ്റ് ചെയ്ത് ഒരു യൂണിറ്റ് സെൽ ആക്കുവാണെങ്കിൽ ഇവന്റെ നടുക്കിരിക്കുന്ന എത്ര ആളുണ്ടാവും? ഇവന്റെ നടുക്ക് ഇവിടെ ഒരാളുണ്ട്, ഇവിടെ ഒരാളുണ്ട്, ഇവിടെ ഒരാളുണ്ട്, ഇവിടെ ഒരാളുണ്ട്, ഫ്രണ്ടിൽ ഒരാളുണ്ട്, പിറകിൽ ഒരാളുണ്ട്. അപ്പോൾ അതിന് ചുറ്റും 6 ആൾ വരില്ലേ? അപ്പൊ എക്സ് എന്ന് പറയുന്ന ആൾ ആരായിരിക്കും? 6 ആയിരിക്കും. ഇനി അടുത്തത് ഫേസ് സെന്റേഡ് ക്യൂബിക്. ഫേസ് സെന്റേഡ് ക്യൂബിക്കിന്റെ നെക്സ്റ്റ് നിയറസ്റ്റ് കാണാൻ എന്താ ചെയ്യുക? അക്ഷയ വേണമെങ്കിൽ ഒരു കാര്യം ചെയ്തോളൂ. ഒരു ഫേസ് സെന്റേഡ് ക്യൂബിക്കിൽ ഒരു കോർണർ പാർട്ടിക്കിളിന് നോക്കിക്കോളൂ സൗകര്യത്തിന്. ഇവിടെ ഒരു കോർണർ പാർട്ടിക്കിൾ ഉണ്ട്. അതിന്റെ നിയറസ്റ്റ് ആരാ? അതിന്റെ നിയറസ്റ്റ് ഫേസിന്റെ സെന്ററിലുള്ള ആളാ. അത് എന്നോട് ചോദിച്ചിട്ടില്ല അത്രയാണ്. അതിന്റെ നെക്സ്റ്റ് നിയറസ്റ്റ് ഏതാണെന്നറിയോ അക്ഷയക്ക്? ഈ കോർണർ കഴിഞ്ഞാൽ പിന്നെ ഈ കോർണറിലുള്ള ആള് തൊട്ട ഫേസ് സെന്ററിലുള്ള ആളാണ് ഏറ്റവും അടുത്ത്, പിന്നെ കോർണറിലുള്ള ആള്. ഇയാൾ അതിന്റെ നെക്സ്റ്റ് നിയറസ്റ്റ് ആണ്. ഇത് നെക്സ്റ്റ് നിയറസ്റ്റ് ആണ്. അതേപോലെ തന്നെ മുന്നോട്ട് പ്രൊജക്ട് ചെയ്യുകയാണെങ്കിൽ പുതിയൊരു യൂണിറ്റ് സെല്ല് വരില്ലേ, അതിന്റെ നടുക്കുള്ളത് അതിന്റെ കോർണറിലുള്ള ആള്, പിന്നെ ഇവിടെയുള്ള ഒരാളുണ്ട് അല്ലെ. അതേപോലെ താഴേക്കുണ്ട്. ഇപ്പൊ ഇതില് ഇയാള് എന്താണ്? ഇയാൾ എന്ന് പറയുന്നത് ഫസ്റ്റ് നിയറസ്റ്റ് ആണ്. ഇപ്പൊ നെക്സ്റ്റ് നിയറസ്റ്റ് എത്ര ആളുണ്ട്? 6 ആളില്ലേ? അത് ആണ് നെക്സ്റ്റ് നിയറസ്റ്റ്. ഇപ്പൊ 6 - 6 0 അല്ലേ കിട്ടിയേ? മനസ്സിലായോ? ഇനി സായിദ് എന്താ ചോദിക്കണേ? ക്വസ്റ്റ്യൻ നമ്പർ 61 ആണ് ചോദിക്കുന്നത്. ക്വസ്റ്റ്യൻ നമ്പർ 61 ഇത്തിരി ലെങ്ത് എടുത്തു നമ്മൾ അല്ലേ. ക്വസ്റ്റ്യൻ നമ്പർ 61 ഒന്ന് നോക്കിയിട്ട് നമുക്ക് കൺക്ലൂഡ് ചെയ്താലോ. ക്വസ്റ്റ്യൻ നമ്പർ 61, ക്വസ്റ്റ്യൻ നമ്പർ 61 ഇരിക്കുന്നത് ഇത് ഭയങ്കര സിമ്പിൾ ആണ്. സായിദിന് ഞാനൊരു എളുപ്പപ്പണി പറഞ്ഞിട്ടില്ലേ? അതായത് M.98O എന്നുള്ളത് സായിദിന് എങ്ങനെ വിചാരിക്കാം? M98O100 എന്ന് വിചാരിച്ചൂടെ സായിദ്? M98O100 എന്ന് വിചാരിക്കാം. ഇതിനകത്ത് M2+ ഉണ്ട്, M3+ ഉണ്ട്, O2- ഉണ്ട്. സായിദിനറിയാം എല്ലാ ക്രിസ്റ്റലും ഇലക്ട്രിക്കലി ന്യൂട്രൽ ആയിരിക്കണം. എല്ലാ ക്രിസ്റ്റലും ഇലക്ട്രിക്കലി ന്യൂട്രൽ ആവണമെങ്കിൽ ടോട്ടൽ പോസിറ്റീവ് ചാർജ് ടോട്ടൽ നെഗറ്റീവ് ആയിരിക്കണം. ഇത് 100 ഓക്സൈഡ് ഉണ്ടെങ്കിൽ ടോട്ടൽ നെഗറ്റീവ് ചാർജ് -200. അപ്പോൾ പോസിറ്റീവ് എല്ലാം കൂടി ആഡ് ചെയ്താൽ +200 കിട്ടണം. സപ്പോസ് ദിസ് ഈസ് എക്സ്, ഇത് 98 - x എന്ന് എടുത്തൂടെ? ടോട്ടൽ പോസിറ്റീവ് ചാർജ് എന്താ? 2x + 3 × 98 - x. ഇത് ചെയ്താൽ 200 കിട്ടണം. പിടികിട്ടിയോ? അതിൽ നിന്ന് എക്സ് കണ്ടുപിടിക്കാം. എക്സ് നിന്ന് 98 - x കാണാം. ഇതിൽ നിന്ന് എക്സ് സോൾവ് ചെയ്ത് നോക്കണം. ഇതിൽ നിന്ന് എക്സ് സോൾവ് ചെയ്താൽ 4 എന്നാ കിട്ടുക. ആണോ? എക്സ് സോൾവ് ചെയ്താൽ 4 അല്ല കിട്ടുക, 94 എന്നാ കിട്ടുക അല്ലേ. എന്നിട്ട് അതിൽ നിന്ന് എന്തായിരിക്കും? ഞാൻ 98 - x അന്നേരം എടുത്താൽ എന്താ കിട്ടുക? 4 എന്ന് കിട്ടും. പിടികിട്ടിയോ? നമുക്ക് കൺക്ലൂഡ് ചെയ്തേക്കാം അല്ലേ. ഇനി എന്തെങ്കിലും ഉണ്ടോ? അക്ഷയ്ക്ക് എന്താ സംശയം? ക്വസ്റ്റ്യൻ അങ്ങനെ പറഞ്ഞിട്ടുണ്ടായിരുന്നു, കോർണർ പാർട്ടിക്കിളും എല്ലാം മിസ്സായേ എന്ന്. ഏത് വേണേ എടുക്കാം, ഏത് പാർട്ടിക്കിളും നിയറസ്റ്റ് നൈബറിലേക്ക് എടുക്കാം. ഓക്കെ, താങ്ക് യു.